Okay, good evening. Today, this is the session. Basics of Signals and Systems, Part 2 of Models 6 to 10. Okay, Models 6 to 10. Already Part 1 లో 1 to 5 చెప్పుకున్నాం. ఇప్పుడు Part 2 లో 6 to 10. Okay, Model 6. Model 6 on difference equations. Okay, difference equation. Already we know what are differential equations. So here difference equation. See here, this is the example 11. Okay, example 11 difference equation. Okay, this belongs to unit 2. Okay, in syllabus it belongs to unit 2. Okay, 1 second. Okay. Okay, this belongs to unit 2 and this is model 6. Okay, model 6, and this model is difference equation. Difference equation. Already we know difference equation belongs to discrete time. Okay, difference equation belongs to discrete time, whereas a differential equation belongs to continuous time. Okay, differential equation belongs to continuous and a difference equation belongs to discrete. Okay, now we are going to discuss about the difference. Okay, now in model 6 difference equation, this is the example 11. Okay, example 11. In this example, this is the difference equation. Okay, difference equation in discrete signals or discrete system, the variable is n. Okay, in continuous variable is t, and in discrete variable is n. T for continuous, T for continuous, and n for discrete. So n is the n. If n is there, that is the discrete time. Okay, if t is there, that is a continuous time. So the reference is Signals and Systems Oppenheim, page number 123 and example 2.15. Okay, this is the prescribed standard textbook prescribed by the JNTU. Okay, so from the textbook, this is the reference. Now, this is the given. 1 second. Okay. Now, this is the difference equation. In this difference equation, y of n minus 1 by 2, y of n minus 1 is equal to x of n. Here we have only n minus 1. N minus 1 means it is like a single differential equation. Okay, it is like a single differential equation, that is dy of t by dt plus 2y of t is equal to x of t. Okay, this is single differential equation, okay, of order 1. Here also this is a difference equation of order 1. Okay, if we have y of n minus 1 plus y of n minus 2. Okay, like that, if you have n minus 2, that is the second order difference equation. Okay, like d square y of t by dt square plus 4 dy of t by dt plus y of t, that like. Okay, yes, this is the second order differential equation, and whereas this one is called a second order difference equation. Okay, so this is second order difference equation, this is second order differential equation, and this is a first order. Okay, this is called a first order difference equation, first order difference equation. So y of n minus 1 by 2 y of n minus 1 is equal to x of n. In this one, y of n is called output, and y of x of n is called input. Okay, now we have to find what we have to find, impulse response. Okay, we have to find a impulse response. We have to find a impulse response. Okay, now to find a impulse response, you have to arrange this equation so that y should be in a left hand side and remaining in a right hand side. So y of n is equal to x of n plus 1 by 2 y of n minus 1. Okay, now this is the equation for n greater than 0. Okay, n greater than 0. Whenever n less than or equal to minus 1, these equation can be 0. Okay, this equation can be 0. For less than minus 1, this equation is 0. So we represent n minus 1. Okay, whenever whenever n less than or equal to minus 1, then x of n is 0, y of n is 0, y of minus 1 also 0. Okay, so treat this one as a initial conditions. Okay, initial conditions, initial condition, and whenever you take any value, that value should be greater than 0. Okay, next to find impulse response. Okay, to find impulse response, okay, we have to put a value n is equal to 0, n is equal to 1, n is equal to 2, and so on. Okay, and find the value and find the general sequence. Okay, find the general sequence. Okay, that general sequence is the impulse response. Okay, already we know this type of problem, this type of steps in previous class. Okay, so here x of n is equal to delta of n into k. Okay, we take a input. Okay, we take a input as a delta of n. Delta of n is called what is the signal? Impulse signal. Impulse signal. Okay, for impulse signal at a delta of 0, delta of 0 value is 1. Okay, delta of 0 value is 1. Okay, now y of 0, put n is equal to 0, the equation becomes x of 0 plus 1 by 2 y of n minus 1. N minus 1, here n is 0, so 0 minus 1, okay, is equal to some value k. Okay, let it be k value. Now x of 0 is delta of 0 into k. Okay, plus 1 by 2 into 0, y of minus 1, y of minus 1 is 0. Already we know y of minus 1 is equal to 0 because no value is given. See here, in previously, what is this value? Y of minus 1. Okay, y of minus 1, y of n, values are always 0. Okay, so here y of minus 1, y of 0, values are 0. So this y of minus 1 value is 0. So 1 by 2 into 0. Now the value of k of delta of 0. K of delta of 0. Already we know delta of 0 is equal to 1. Okay. From here, delta of 0 is equal to 1. Impulse response at 0 at t is equal to 0 or n is equal to 0. Value is 1. So k into 1 k value. Now what is this value? Y of 1. Y of 1 value. Now we have y of 1 value is equal to k. Okay. Sorry, y of 0. Y of 0. This is y of 0. Y of 0 value is k. Okay. Next, put n is equal to 1. N is equal to 1. Now x of 1 plus 1 by 2 y of here 1 minus 1. 1 minus 1 is 0. Okay. 1 minus 1 is 0. Now x of 1. X of 1 is k into delta of 1 plus y of here 0. Already we know y of 0 is equal to k value. So 1 by 2 into k, this value is 0. Okay. Why? Because we have delta of 0 is equal to 1. Other than delta of 0, every value is 0. Okay. Now delta of 1 is equal to 0, delta of 2 is equal to 0, delta of 3 is equal to 0, delta of n also is equal to 0. Only when delta of 0 is equal to 1. Okay. Now delta of 1 is equal to 0, k into 0, 0 plus 1 by 2 into k. Now the value is 1 by 2 into k. Now we have y of 1, y of 1 value is 1 by 2 into k. Okay. Now put n is equal to 2. N is equal to 2, x of 2 plus 1 by 2 into y of 2 minus 1. Okay. 2 minus 1, 1. Now k of delta 2. We know delta 2 is equal to 0. Okay. Next 1 by 2 into, okay, 1 by 2 into, now see 1 by 2 into y of 1. What is y of n? 1 by 2 into k. So 1 by 2 into k by 2. Now the value is k by 4. Okay. K by 4 can be written as a 1 by 2 into 1 by 2 whole square into k. Okay. That is y of 2. Similarly, y of 3. Y of 3, x of 3 plus 1 by 2 into y of 2. Okay. Delta of 3. Delta of 3 is 0. Okay. 1 by 2 into 1 by 2 k by 3. That is 1 by 2 whole cube into k. Okay. 1 by 2 into whole cube into k. That is y of 3 and so on. Now the sequence is 1 by 2 whole power n into k. This is the sequence. So here output is completely characterized by its impulse response. Setting k is equal to 1. Okay. Now put k is equal to 1. Okay. Put k is equal to 1. We have 1 by 2 whole power n into k. Okay. Now in place of 1, generally in place of 1 in continuous we put x of t. But here it is discrete. For discrete put u of n. So in place of 1 u of n. Okay. This is the answer. Next. In the same model, next problem. Okay. In the same model, next problem. Now it is second order difference equation. This is second order difference equation. Okay. Previous problem is first order difference equation. Now it is second order difference equation. How will you know this is second order difference equation? Y of n minus 2. Here we have y of n minus 2. So it is called second order difference equation. Okay. Here, see here, already we write here, I write here, for continuous time, this is called differential equation. For discrete time, it is called a difference equation. Okay. Now, taking this equation on arranging left side, only y of n should be there. Remaining are right side. Okay. So this is the equation. Okay. This is the equation arranging y of n is equal to like that. Okay. Now x of n is equal to delta of n. Again, we are taking impulse response as the input. Okay. So here impulse response as the input. Okay. Delta of n. Next, y of minus 2. Y of minus 2, y of minus 1 is equal to 0 because n always greater than 1. Okay. Or n always greater than 0. Okay. When n less than minus 1, every value is 0. So y of minus 1 is 0, y of minus 2 is 0, y of minus 3 is 0, y of minus 4, minus 5 and so on. All values should be 0. Okay. And now again previous problem process. Okay. Put n is equal to 0. Okay. Put n is equal to 0. Now what is the value? See here. Now put n is equal to 0. Whenever n is equal to 0, okay, here value is 5 by 6, 5 by 6. Y of 0 minus 1, 0 minus 1, minus 1, minus 1 by 6, minus 1 by 6. Y of 0 minus 2, that is minus 2. Next, 3x of 0, 3x of 0, minus 2x of 0 minus 1, minus 1. Okay, already we know what is x. X is delta of n. Okay, here where is the value? Delta of 0 is the value. Delta of 0 is 1. For remaining values, it is 0. Okay. Delta of 0 is 1. Delta of 1 is 0. Delta of 2 is 0. Delta of 3 is 0. Delta of 4 is 0. Okay.
Ravi minus y of omega sir.
Y of
Y of minus 1, y of minus 2 ఉన్నాయి కదా సార్ అక్కడ డెల్టా
ఉన్నాయి. నేను చెప్తుంది ఇన్పుట్ కి ఇక్కడ మనకు తెలిసి ఏంటి? ఇంపల్స్ రెస్పాన్స్ ఈస్ 1 ఎట్ n is equal to 0. Okay. At n is equal to 0, that is 1. Remaining any value, it is 0.
sir.
Okay. Now y of minus. Okay. Sir. Y of minus 1. Here y of minus 1 is 0. Already we know y of minus 1 is 0. Okay. Here. Next, y of minus 2. Y of minus 2 is also 0. So 0. X of 0. X of 0 means delta of 0. Already we know that delta of 0 is 1. So in this value 1. Next, here x of minus 1. X of minus 1 means delta of minus 1. Delta of minus 1 is 0. Okay. Next, here value is 0 minus 0, 3 minus 0. So value is 3. Now y of 0 value is 3. Okay. Next, y of 1. Put n is equal to 1. Put n is equal to 1. Now 5 by 6 y of 1 minus 1. 1 minus 1 is 0. Next 1 minus 2, that is minus 1. Next 0. Here x of 1, x of 1. Next x of 1 minus 1, 0. Okay. Now y of 0. Y of 0 value, already we know y of 0 value, that is 3. So here this value is 3. Okay. From above. Next, minus 1 by 6 y of minus 1. Already we know y of minus 1 is 0. So 0. X of 1. X of 1 is also 0. X of 1 means x of 1, that is delta of 1. Delta of 1 value is 0. Next, x of 0. X of 0 means x of 0, delta of 0. We know delta of 0 is equal to 1. So here x of 0 means delta of 0 is equal to 1. Okay. Now the value is here 5 by 2, 5 by 2 minus 2, that is 1 by 2, that is 3 by 6. Okay. Next, y of 2. Put n is equal to 2. Put n is equal to 2. 2 minus 1, 1. Y of 1. Okay. 1 by 6. Y of 2 minus 2, 0. Okay. Next, x of 0. X of 2. X of 2. Here x of 2 minus 1. 2 minus 1 is 1. Already we know y of 1. Y of 1, what is the value? Y of 1 value is, we can put 1 by 2 or 3 by 6. So here put 1 by 2. 1 by 2. Here y of 0. Y of 0 also we know y of 0 value is 3. Put 3. X of 2. X of 2 means x of 2
0.
Hey, Trizavanand.
Trizavanand.
చెప్పండి రా.
చిట్టబాబు కెమెరా ఆన్ చే.
ఆన్ చేయను. సారే రా.
ఇంటికి వెళ్ళారు సార్.
చెప్పమని క్లాస్.
హలో
సార్ వెల్కమ్ బ్యాక్ టు.
అదే కరెంట్ పోయింది.
ఓకే
ఓకే కాదు, రికార్డింగ్ ఇంకా ఉందా? రికార్డింగ్ ఉందా?
రికార్డింగ్ ఉంది.
రికార్డింగ్ లోనే ఉందా?
రికార్డింగ్ లోనే ఉంది సార్.
అవును సార్, రికార్డింగ్ ఉంది సార్.
ఓకే ఓకే, డన్ డన్.
కనబడుతుందిరా? ఎక్కడ కనబడుతుంది?
ఓకే, స్క్రీన్ డిస్ప్లే అవుతుందా?
ఎస్ సార్.
ఎస్ సార్.
ఓకే డన్.
సార్
ఓకే
సార్.
చెప్పండి.
అది ఫస్ట్ ఆర్డర్ కి సెకండ్ ఆర్డర్ కి డిఫరెన్స్ ఏంటి సార్?
ఫస్ట్
ఆర్డర్ కి సెకండ్ ఆర్డర్ కి.
ఫస్ట్ ఆర్డర్ లో we have up to y of n-1 only. In second order we have term called y of n-2 also.
ఓకే సార్.
Okay,
ఓకే సార్.
next y of 2. Y of 2 we have y of 1 value. What is the y of 1 value? 1/2. Okay, put here 1/2. Next y of -1, we know the value y of -1 is 0, so put y of -1. Okay, y of 0. Here already we know y of 0. What is the value y of 0? Y of 0 value is 3.
3.
Okay, put y of 0 is 3. Next x of 2. X of 2 means x of
0.
2 0. Delta of 2. Delta of 2 is 0. Next x of 1 means that is
0.
delta of 1 0. Okay, now calculate these value, we will get -1/12. Okay, now
Okay, sir.
so on we calculate these values. Okay, so on calculate these values and depending upon these sequence, what is the sequence? First it is 3, next it is 3/6, next it is -1/12. Okay, and so on. With this sequence all are, we can write this value is 3, 3/6, -1/12, that like. Okay, this is the problem. Next is the problem 7. Okay, example 7. These example 7 also has a n-2 term, so this is a
చాలు సార్.
second order differential
సెకండ్
equation.
ఆర్డర్.
Okay, now for this
హలో, సీక్వెన్స్ ఎలా
చెప్పండి.
కనబడితే చాలు సార్.
చెప్పండి.
సీక్వెన్స్ అలా కనబడితే చాలా సార్.
కనిపెడితే సరిపోతుంది. ఒకవేళ మీకు సీక్వెన్స్ తెలిస్తే రాస్తారు, లేదంటే అలా వదిలేస్తారు. నో ప్రాబ్లం.
ఓకే సార్.
ఓకే, ఇక్కడ చూడండి n-2. ఓకే, n-2 means this is the second order difference equation. Okay, second order difference equation. See here, ఇక్కడ రాశాను సెకండ్ ఆర్డర్ డిఫరెన్స్ ఈక్వేషన్. ఈ ఈక్వేషన్ ఏమంటున్నాడు ఇక్కడ? ఆల్రెడీ క్వశ్చన్ ఇచ్చాడు, క్యాజువల్ LTI difference system. Okay, casual LTI difference system. LTI means linear time invariant. Okay, LTI means linear time invariant. Okay, so these linear time invariant is the most important term in our subject, because each and every chapter, each and every topic related to LTI only. Okay, so LTI difference system, we take this LTI difference system. Now what we have to find from this? We have to find the h of n. Okay, here we have to find h of n. H of n is called impulse response. H of n is called impulse response. Okay, so first of all, this is the second order equation. From this second order equation, we have to find a characteristic equation. Okay, characteristic equation. What is the characteristic equation? This is taken in a Z. Okay, ఈ equation మనం Z లో తీసుకో. We can take this equation in Z transform or Laplace transform. Okay, Z transform or Laplace transform. Here he taken in a Z transform. Okay, this equation is taken in a Z transform. So in Z transform, here Z transform of y of n is y of z. Okay, next Z transform of y of n minus 1. Okay, n minus 1. N minus 1 is called a z into y of z. Okay, z into y of z. Okay, next and so on. That like a z square into here. This is the second order, so z square. That like. Okay, equation తీసుకుంటే simply remember that neglect these terms. Okay, neglect these terms. This is second, already we know this is the second order equation. So this is second order equation we taken in Z transform. So z square minus 0.5 z plus 0.06 z. Okay, characteristic equation ఎలా తీసుకున్నాం? Z square minus 0.5 z plus 0.06 into 1. Okay, take like that as a characteristic polynomial. This characteristic polynomial find the factors. Okay, find the factors z minus 0.6, z minus 0.3. So factors are 0.2 and 0.3. Okay, 0.06 factors ఏమొస్తాయి? 0.2, 0.3. Okay, 0.2, 0.3 minus 0.2 minus 0.3. Okay, minus 0.2 into minus 0.6, 0.06. 0.2 plus 0.03, 0.03. This is minus 0.5. Okay, we will get here minus 0.5. So here Z1 is 0.2 and Z2 is 0.3. Now homogeneous equation. Whenever homogeneous equation, already we know whenever we have two roots, okay, clear roots, the equation is A into 0.2 whole power n plus b into 0.3 whole power n.
Sir?
This is the standard equation. చెప్పండి. ఇది Z ట్రాన్స్ఫార్మ్ లో. అదే ప్రీవియస్ గా ఒక చెప్పుకున్నాం, ఇది ఈ ఇంపల్స్ రెస్పాన్స్ చెప్పుకున్నాం. ఇంపల్స్ రెస్పాన్స్ లో హోమోజెనస్ ఈక్వేషన్ ఏంటి? a1 e పవర్ మైనస్ 3t ప్లస్ a2 e పవర్ మైనస్ 2t. ఓకే, అక్కడ ఈక్వేషన్ ఏమైంది? అక్కడ ఈక్వేషన్ లాప్లాస్ తీసుకున్నాం. ఓకే, అక్కడ ఈక్వేషన్ లాప్లాస్ తీసుకున్నాం. లాప్లాస్ తీసుకుంటే s ప్లస్ 3 ఇంటూ s ప్లస్ 2. అప్పుడు ఎంత అయింది? s ఈజ్ ఈక్వల్ టు మైనస్ 3, s ఈజ్ ఈక్వల్ టు మైనస్ 2. అప్పుడే వాట్ ఈస్ ది హోమోజెనస్ సొల్యూషన్? a1 ఇంటూ e పవర్ మైనస్ 3t ప్లస్ a2 ఇంటూ e పవర్ మైనస్ 2t. Okay, whereas in Z transform we take here constant a and b, and in place of 0.2 we write 0.2 whole power n into 0.3 whole power n. Okay, this is the form of Z transform. Okay, in Z transform we take this form. Okay, ఈ ప్రాక్టీస్ చేయండి మీరు ఇలా. నెక్స్ట్, when n greater than 0, always we find a greater than 0. Okay, n should be always greater than 0. Okay, now we are taking a initial condition. Why you taking initial conditions? To find the value of a and b. Okay, now h of minus 1 is 0, s of 0, that is delta of 0 is 1. Although we know every time delta of 0 is 1. Okay, now put n is equal to minus 1. Okay, put n is equal to -1, a 0.2. What is the value of n? -1. Okay, what is the value of n? -1. Okay, now h of 0 minus h of -1. h of -1 is 0, 0. This is 0.2, that is 1 by 0.2. 1 by 0.2, that is 5. Next, 1 by 0.3, 10 by 3 b. This is the equation 1, and this is the equation 2. Okay, this is the equation 2. How this equation 2 came? Put n is equal to 0. Okay, in this equation, put n is equal to 0. So this is 0. 0.2 power 0 is 1. 0.3 whole power 0 is 1. A plus b. Okay, a plus b is equal to 1. H of 0. Already we know h of 0 is delta of 0 is equal to 1. So with these two equations, find a and b value. A is equal to -2, b is equal to 3. Put these values in this equation, and hence the value, that is impulse response, is obtained. Okay, impulse response is obtained. So h of n minus 1. Here taking n minus 1. Why n minus 1? If it is h of 0, it is considered as a initial condition. Okay, so we taking h of n and also h of n minus 1. Put in place of n, put n is equal to n minus 1. Okay, n minus 1 here into 1. Already we know here into 1. In place of 1, we have to write u of n. Okay, here u of n, but here each and every term has n minus 1. So here you have to write u of n minus 1. If it is n minus 2, write n minus 2. n minus 3, write here n minus 3. Okay, next. So this model is completed. This model is completed, and another example is taken. This is the equation. One second. Okay.
సార్
Now see, చెప్పండి.
సార్ ఇందులో సెకండ్ ఆర్డర్ వేరే మోడల్ చెప్పారు, ఇప్పుడు మళ్ళీ వేరే మోడల్ చెప్పారు సార్, అదే సెకండ్ ఆర్డర్.
సెకండ్ ఆర్డర్.
ఆహా,
మీరు ఏం
ప్రీవియస్ గా
చేస్తారంటే
వేరే మోడల్ చెప్పారు
ఇదే
సార్.
ఫాలో అవ్వండి. ఇది జనరల్, ఇది ఉంది కదా సెకండ్ ఆర్డర్.
ఎస్ సార్.
ఇది జనరల్ ప్రొసీజర్.
మరి ఇప్పుడు చెప్పింది సార్.
ఇప్పుడు జనరల్ ప్రొసీజర్ తర్వాత మనకి ఇంకా ఏమున్నాయి? లాప్లాస్ ట్రాన్స్ఫార్మ్ ఉంది, జెట్ ట్రాన్స్ఫార్మ్ ఉంది. ఓకే, సో ఇక్కడ చెప్పింది ఏంటంటే జెట్ ట్రాన్స్ఫార్మ్ తీసుకొని చెప్పాం
సార్. మరి ఏ మోడల్ లో చేయాలి సార్? ఒకసారి క్వశ్చన్ ఇస్తే.
వాడు 50 యూనిట్లు ఇచ్చాడు అనుకోండి. 50 యూనిట్ అంటే ఏంటి? జెట్ ట్రాన్స్ఫార్మే కదా.
ఎస్ సార్.
జెట్ ట్రాన్స్ఫార్మ్ ఇస్తే ఈ మోడల్ ఫాలో అవుతారు, అంటే ఈ మెథడ్ ఫాలో అవుతారు.
సెకండ్ యూనిట్ లో ఇస్తే జనరల్ ఫార్మ్.
సెకండ్ డిఫరెన్స్ ఈక్వేషన్ అంటే ఇది యూనిట్ 2. యూనిట్ 2 లో ఇస్తే జనరల్ ప్రొసీజర్.
ఓకే సార్.
ట్రాన్స్ఫార్మ్ లాస్ట్ సార్.
జెట్ ట్రాన్స్ఫార్మ్ లాస్ట్ లో ఇస్తాడు. ఇంకోటి ఏముంది? ఫోరియర్ ట్రాన్స్ఫార్మ్ కూడా ఉంది కదా. చెప్పండి
సార్. లాప్లాస్ ట్రాన్స్ఫార్మ్ ఏ యూనిట్ సార్?
లాప్లాస్ ట్రాన్స్ఫార్మ్ 5th యూనిట్ పార్ట్ 1. జెట్ ట్రాన్స్ఫార్మ్ 5th యూనిట్ పార్ట్ 2.
ఓకే సార్.
ఫోరియర్ ట్రాన్స్ఫార్మ్ యూనిట్ 4. ఫోరియర్ ట్రాన్స్ఫార్మ్ ఇది ఫోరియర్ ట్రాన్స్ఫార్మ్ అనేది యూనిట్ 3 పార్ట్ 2. ఓకే, నెక్స్ట్ యూనిట్ 4 లో కూడా ఫోరియర్ ట్రాన్స్ఫార్మ్ ఉంది. అంటే ఈ ఫోరియర్ ట్రాన్స్ఫార్మ్ లో అప్లికేషన్స్ అడుగుతాం. యూనిట్ 4 ఫోరియర్ ట్రాన్స్ఫార్మ్ లో అప్లికేషన్స్ అడుగుతాం. ఓన్లీ ఫోరియర్ ట్రాన్స్ఫార్మ్స్ అంటే యూనిట్ 3 పార్ట్ 2.
ఓకే సార్.
ఓకే, అంటే ఇది మోడల్ నేను ఏం చెప్తున్నానంటే డిఫరెన్స్ ఈక్వేషన్ ఉన్నప్పుడు వెన్ ఎవర్ హ్యావ్ డిఫరెన్స్ ఈక్వేషన్ వెదర్ ఇట్ ఈస్ సెకండ్ యూనిట్, ఫిఫ్త్ యూనిట్ ఆర్ ఫోర్త్ యూనిట్, డిఫరెంట్ మోడల్స్ చెప్తాను అనమాట. అంటే ఈ మోడల్లో డిఫరెంట్ మెథడ్స్ చెప్తాను. ఓకే, దిస్ ఈస్ జనరల్ మెథడ్ అండ్ దిస్ ఈస్ జెట్ ట్రాన్స్ఫార్మ్ మెథడ్.
ఓకే సార్.
ఓకే, నెక్స్ట్ ప్రాబ్లం. ఇది కూడా మోడల్ 6. దిస్ ఆల్సో మోడల్ 6. Model 6. Okay, not this example, this example. Okay, this example is again jet transform. This is the jet transform. ఈ మెథడ్ ని చూస్ చేసుకోండి. ఇంకా ఓకే, ఈ మెథడ్ ని చూస్ చేసుకోండి. ఇంకా జెట్ ట్రాన్స్ఫార్మ్లు ఇస్తే ఇదే మెథడ్ ఫాలో అయిపోండి. ముందు మెథడ్ వద్దు, ఈ మెథడ్ వద్దు.
ముందే ఈజీగా ఉంది సార్.
ఇదే ఈజీగా ఉందా?
ఎస్ సార్.
ఓకే, సరే, మీకు ఏది కన్వీనియంట్ కూడా అది ఫాలో అవ్వండి. జెట్ ట్రాన్స్ లో 2 రకాలు చెప్తున్నాను, ఇదొకటి, నెక్స్ట్ ఇదొకటి.
ఓకే సార్. సో ఇది ఒకసారి ఎక్స్ప్లెయిన్ చేయండి సార్. ఈ మోడల్ ఒకసారి ఎక్స్ప్లెయిన్ చేయండి సార్.
ఇది ఇప్పుడే ఎక్స్ప్లెయిన్ చేస్తాను. ఇప్పుడు ఇదే. ఓకే,
ఓకే.
నౌ దిస్ ఈస్ ది మోడల్ 6. సారీ, ఒకసారి. దిస్ ఈస్ మోడల్ 6 difference equation, second order difference equation in jet transforms. Okay, in jet transform చెప్పుకున్నాం already. How you know this is the second order difference equation? Because it has a n-2. Okay, this has n-2, so it is the difference equation. Now see here n-2 is there, so it is the second order difference equation. This is the method in a jet transform. Okay, so apply jet transforms on both sides. Okay, apply once. Wait, Fourier transform sir unde jet transform, Fourier transform idi oka nimisham. mistake. Okay, it's Fourier transform. Sorry, this is the Fourier transform. This is the Fourier transform unit 4. Fourier transform unit 4. నేను జెట్ ట్రాన్స్ఫార్మ్ చెప్తాను చూడండి. ఇది జెట్ ట్రాన్స్ఫార్మ్ కాదు, ఇది ఫోరియర్ ట్రాన్స్ఫార్మ్ యూనిట్ 4. ఓకే, ఇక్కడ జెట్ ట్రాన్స్ఫార్మ్ ఏంటంటే ఇది జెట్ ట్రాన్స్ఫార్మ్ యూనిట్ 5 పార్ట్ 2. యూనిట్ 5 పార్ట్ 2 జెట్ ట్రాన్స్ఫార్మ్. ఓకే, దిస్ ఇస్ ది సెకండ్ ఆర్డర్ డిఫరెన్స్ ఈక్వేషన్. ఓకేనా? ఇప్పుడు జెట్ ట్రాన్స్ఫార్మ్ చెప్తున్నాను చూడండి. Now see here, second order difference equation. Here also we have to find h of z. Okay, h of z, we have to find a difference equation. For the difference equation, we have to find a impulse response. Okay, impulse response, and with the impulse response, we have to find a system is stable or casual. Okay, this is the difference equation. How we know this is a difference equation? Y of n-2. Here we have n-2, so it is the second order difference equation. Okay, okay, now this is the given equation. For this given equation, apply jet transforms on both sides. Okay, now apply jet transform on both sides. Okay, next On applying Z transform on both sides, here we have y of z. Okay, y of z minus 9 by 4. Here we have already n minus 2. ఒకసారి ఈక్వేషన్ రాస్తున్నాను చూడండి. Y of n, that's the equation. Y of n minus 9 by 4 y of n minus 1 plus 1 by 2 y of n minus 2, that is equal to x of n minus 3 into x of n minus 1. Okay, ఇది given equation. Okay, పైన ఉన్నది given equation. Okay, above is the given equation. When we apply Z transform on both sides, Z transform of y of n is y of z minus 9 by 4 y of n minus 1. Okay, here y of n minus 1. Here we have n minus 1. 1 means z power minus 1 y of z plus 1 by 2. Now we have n minus 2. Minus 2, so z power minus 2 into y of z plus x of n. X of n is x of z minus 3 of z minus 1. N minus 1. Minus 1 means z power minus 1 x of z. Okay, this is the formula. Okay, if it is n minus 1, z power minus 1. If it is n minus 2, z power minus 2. If it is n minus 1, z power minus 1. Okay, got it? This formula?
Yes, sir.
Okay, next, take the y of z common. Okay, y of z common, we have 1 minus 9 by 4 z inverse plus 1 by 2 z power minus 2. Okay, here take x of z common. X of z 1 minus 3 z power minus 1. Okay, now arrange y of z by x of z. Now arrange y of z by x of z. Y of z by x of z is equal to, this is the value. Okay, now we want this equation in terms of z square, not z power minus 2. Okay, we want this equation in case of z square. Okay, so multiply and divide with z square. Okay, multiply and divide with z square, we have z into z minus 1, z square minus 9 by 4, z plus 1 by 2. Okay, now this is the final equation. This equation is called h of z. Okay, system function h of z. This h of z is called y of z by x of z, and also this is called a transfer function or a frequency response. Okay, already man formula చెప్పుకున్నాం. h of omega or h of z is called a frequency response or transfer function. Okay, already we know what is a transfer function. Transfer function is output by input. So output by input is transfer function. Okay, now find the factors of this one. Okay, what are the factors? Minus 1 by 4 and 1 by 4 and 2. Okay, factors z minus 1 by 4, z minus 2. Next, remember one thing. This is very, very important point. Remember one thing. In z transforms, we have one z extra here. Okay, remember one. This is a very, very important point. Remember one thing. In z transforms, always we have one z in a numerator. Okay, when we got a z in numerator, that is the correct procedure. Okay, now we have to take this z to left hand side. So this will be multiplying. Here it is division. So h of z by z. Okay, h of z by z. Now remaining term. What is the remaining term? This one. That is z minus 3, z minus 1 by 4, z minus 2. This is the remaining term. For this remaining term, we can apply partial fractions. Okay, we can apply partial fractions. A by z minus 1 by 4, b by z minus 2. That is, this is the value. Okay, now what is the a value? A value is 11 by 7. What is b value? Minus 4 by 7. Okay, you know this value. How this value can be obtained? A and b value using partial fraction. ఎవరైనా చెప్తారా? ఎవరైనా చెప్తారా? పార్షియల్ ఫ్రాక్షన్స్ లో ఏ వాల్యూ బి వాల్యూ ఎలా ఫైండ్ చేస్తాం? షార్ట్ కట్ మెథడ్. ఓకే, ఇక్కడ హెచ్ ఆఫ్ జెడ్ వచ్చింది. ఇది కంప్లీట్ అయిపోయిందని చెప్తాను ఎలాగన్నది. ఇదే ఈ పార్షియల్ ఫ్రాక్షన్స్ ఉన్నాయి కదా, దీస్ పార్షియల్ ఫ్రాక్షన్స్ కెన్ బి calculated, okay, using shortcut method. Okay, all types of partial fractions and each and every method obtained in each and every unit is taken as a model number 10. Okay, these all partial fractions can be taken as model number 10. Okay, so ఈ ప్రాబ్లం ఏమో చెప్తాను అది. నెక్స్ట్, now what he asked, for system to be stable. Okay, for system to be stable, find the value h of z to h of n. Okay, h of z in a z transform. Now apply inverse z transform. Whenever we apply inverse z transform, we will get a h of n. Now h of n value is whatever may be this value. See here, minus 1/4 and minus 2. Whatever may be this value, this is the answer. Okay, so here 1/4. So 1/4 whole power n u of n plus here what is the value? 2. So here value is 2 power n. This is the formula. Okay, this is the most important formula and maximum used formula. Okay, already given in the important points in unit 5. Okay, unit 5 lo important cheppam already. Unit 5 important formula. Okay, in Z transform. Now we have to find for the system to be stable. Okay, for stable, it's ROC. ROC means region of convergence. Region of convergence must be included in a unit circle. Okay, that is unit circle is Z is equal to 1. Okay, Z is equal to 1. Here we have one value is 1/4. Here values are 1/4. See here, one value is, wait once. Okay, here one value is 1/4. Another value is 2. So the Z lies between 1/4 and Z. This is the ROC. Now what is the condition? Here condition should be, here what is the condition? Unit circle, that is Z is equal to 1. Okay, so Z is equal to 1. 1/4. 1/4 is 0.25. 0.25 lies under 1. This is okay. Now 2 is greater than 1. So this is anti-casual. Okay, left side portion lies in the circle, that is Z is equal to 1. Now right side cannot be outside the circle. So 1 is less than the circle and 1 is greater than the circle. That is both sides we have. So it is called anti-casual. Okay, anti-casual, though the system is stable but non-casual. Okay, anti-casual or non-casual, because here we have only two conditions, that is casual, non-casual. Okay, here we have only two conditions, casual, non-casual. Anti-casual also comes under non-casual. Okay, so system is stable but non-casual. Okay, here asked about the stable, hence it is stable. Why it is stable? Because one value less than circle. Okay, or here condition is circle should be, here condition is the Z is equal to 1 circle should be lies between this value. Okay, lies between this value. Here 0.25 and 2. So unit circle is 1. That 1 belongs to this range. Okay, point out when that.
Yes, sir.
Okay, so 1 lies between this range, so it is stable. Okay, why it is non-stable, non-casual? Because one value less than 1/2 and another value greater than 1. Okay, one is less than 1 and another value greater than 1. So it is non-casual. Okay, next, system to be casual. Already system to be casual when modulus of Z is equal to modulus of Z greater than 2. When we are taking greater than 2. Okay, now we are taking greater than 2. So whenever it is greater than 2, casual. Okay, it is casual. So 1/4 and 2 below the 2. So it is casual, but it is not stable, because for stable we have to consider Z is equal to 1. Okay, z is equal to 1 అనే సర్కిల్ 2 రూట్స్ మధ్యన ఉండాలి. ఓకే, 2 రూట్స్ కి మధ్యన ఉండాలి. ఇక్కడ చూడండి 2 రూట్స్ కి మధ్యన ఉండాలి. z is equal to 1 అనేది 2 రూట్స్ కి మధ్యన ఉంది కాబట్టి ఇట్ ఈస్ స్టేబుల్. ఇక్కడ z greater than 2 means it is not stable. Why? Because z is equal to 1 అనే సర్కిల్ లోపలే ఉంది, బిట్వీన్ లేదు. ఓకే, బిట్వీన్ లేదు కాబట్టి దిస్ ఈస్ అన్స్టేబుల్. ఓకే, now we see how we calculate impulse, that is partial fractions. Okay, partial fractions here. What is the term is z minus 3 by z minus 1 by 4 into z minus 2. Okay, what is this one called? H of z by z. Okay, to calculate a value. Okay, ఇక్కడ a కింద ఏముంది వాల్యూ? what is the value here? z minus 4. so z minus 1 by 4, sorry, z minus 1 by 4 is equal to 0, z is equal to 1 by 4. so to calculate a value we have to put z is equal to 1 by 4. అంటే ఏం చేస్తుంది ఇక్కడ? h of z by z. ఓకే, ఒకసారి here take the term. what is the term? z minus 1 by 4. okay, z minus 1 by 4 into h of z by z. ఓకే, అంటే జనరల్ గా ఏం చేస్తాం? ఏ కింద ఏదైతే వాల్యూ ఉందో ఆ వాల్యూని హైడ్ చేస్తాం. ఓకే, ఈ ఈక్వేషన్ ఉంది కదా, ఈ మెయిన్ ఈక్వేషన్ లో దీన్ని హైడ్ చేస్తాం. ఓకే, దీన్ని హైడ్ చేసి రిమైనింగ్ వాల్యూలో పుట్టి a is equal to 1 by 4, then we get a value. ఓకే, సో ఇక్కడ హైడ్ చేస్తాం అనేది ఇక్కడ ఎలా రాస్తున్నాం అంటే z minus 4 ని మల్టిప్లై చేసేస్తున్నాం. అప్పుడు ఏమవుతుంది? క్యాన్సిల్ అయిపోతుంది కదా. z minus 1 by 4 into hz by z అంటే ఇదే కదా టర్మ్. ఓకే, ఈ టర్మ్ ని డైరెక్ట్ గా రాసేస్తే ఏమవుతుంది? z minus 1 by 4 అనేది క్యాన్సిల్ అయిపోతుంది, ఇది క్యాన్సిల్ అయిపోతుంది. అప్పుడు ఏం మిగిలింది? z minus 3 by z minus 2. ఓకే, at z is equal to ఎంత వాల్యూ? z is equal to 1 by 4. ఓకే, ఇప్పుడు z is equal to 1 by 4. 1 by 4 minus 3, 1 by 4 minus 2. ఎంత అయింది? 4 3s are 12. ఓకే, 4 3s are 12. 12 minus 1 minus 11. minus 11 by 4. ఓకే, నెక్స్ట్ 4 2s are 8. 8 minus 1 minus 7. మొత్తం ఎంత అయింది? 11 by 7. ఈ పాయింట్ అర్థమైందా?
ఎస్ సార్.
ఓకే, సేమ్ ఇప్పుడు బి వాల్యూ. బి కింద ఎంత ఉంది వాల్యూ? z minus 2. కాబట్టి z minus 2 into h of z by z. అప్పుడు ఏమవుతుంది? z minus 2 into z minus 3 by z minus 1 by 4 into z minus 2. z minus 2 క్యాన్సిల్ అయిపోతుంది. అంటే ఇక్కడ z minus 2 రాసామంటే ఖచ్చితంగా ఆ టర్మ్ ని మనం హైడ్ చేస్తాం. ఓకే, ఈ టర్మ్ ఇక్కడ రాసామంటే మీనింగ్ ఏంటి? దిస్ షుడ్ బి హైడ్. ఓకే, అండ్ రిమైనింగ్ టర్మ్, ఇన్ దిస్ రిమైనింగ్ టర్మ్ యూ హ్యావ్ టు పుట్ z is equal to 2. ఓకే, now what is the remaining term? z minus 3, z minus 1 by 4 at z is equal to 2. okay, now 2 minus 3, 2 minus 1 by 4. 2 minus 3 is minus 1 and 4 2s are 8. 8 minus 1 7. 7 by 4. ఓకే, రివర్స్ చేస్తే ఏమవుతుంది? minus 1 by 7. b వాల్యూ minus 1 by 7 and a value is 11 by 7 and b value is minus 4 by 7. okay, this is a shortcut method. ఇక్కడ మీరు ఈ పాయింట్స్ రాయాలి. ఇక్కడ ఏదైతే నేను రాశానో అది యాక్చువల్గా ఇక్కడ ఎగ్జామ్ రాసినప్పుడు ఇక్కడ పార్షియల్ ఫ్రాక్షన్స్, we take partial fractions అని చెప్పేసి a value b value we have to calculate and put in. ఓకే, నెక్స్ట్ ప్రాబ్లం ఏంటి? ఇది ప్రాబ్లం. నెక్స్ట్ ఇది కూడా మోడల్ 6 లో ఫోరియర్ ట్రాన్స్ఫార్మ్ అప్లై చేసినప్పుడు ఇది కూడా డిఫరెన్స్ ఈక్వేషన్ ఎందులోది? యూనిట్ 4. ఓకే, యూనిట్ 4 మోడల్ 6. దిస్ ఈస్ differential equation in unit 4. This comes under Fourier transform. Okay, Fourier transform లో ఎలా క్యాలిక్యులేట్ చేస్తాం చూద్దాం. Here also we have n minus 2, so it is the second order equation. This second order equation we are applying Fourier transform. Fourier transform అప్లై చేసినప్పుడు ఇది కూడా సేమ్ ఇదే. ఇక్కడ n minus 1 ఉంటే ఇక్కడ e power minus j omega వస్తుంది. n minus 2 ఉంటే e power minus 2 j omega వస్తుంది. ఓకే, n minus 1 ఉంటే ఇక్కడ minus 1 ఉంది కాబట్టి e power minus j omega, ఇక్కడ minus 2 ఉంది కాబట్టి e power minus 2 j omega. So here we have n minus 1 e power minus j omega, n minus 2 e power minus 2 j omega. Okay, so for this one Fourier transform is y of omega. Here Fourier transform is minus 3/4 e power minus j omega and y of omega plus 1/8 e power minus 2 j omega y of omega is equal to 2x of omega. Okay, take y of omega common, 1 minus 3/4 e power minus j omega plus 1/8 e power minus 2 j omega is equal to this value. Okay, now we have to find a transfer function. Transfer function formula is output by input. So output by input is equal to this is the value. Okay, now transfer function, in other words, this is called transfer function. This transfer function is also called a frequency response, h of omega. Okay, h of omega, because this is called frequency response or transfer function. This is very, very important point. Okay, frequency response or it is called transfer function. Okay, so frequency response is h of w and transfer function is y of omega by h of omega, this value. Okay, now find the factors. Okay, find the factors and these are the factors. Now apply partial fractions. Okay, apply partial fractions. See here, in the చేసినట్టు చేసాం. Okay, here a term is this one, so this term is multiplied with this total term. Okay, this term, okay, this term is this multiplied with h of omega at e power minus j omega is equal to 2. Okay, put this value is equal to 0. Okay, put this value is equal to 0, we will get a 2. Okay, now this value is, ఇప్పుడు ఏమవుతుంది, ఈ వాల్యూ క్యాన్సిల్ అయిపోతుంది. ఓకే, వాట్ ఇస్ ద రిమైనింగ్ వాల్యూ, 2/1 minus 1/4 e power j omega. So 2/1 minus 1 by e power minus j omega. What is the e power minus j omega value? 2. So put the value 2. Okay, so here 1/2, here 1/2, that is 4. So a value is 4. Next b value. Okay, what is the term? B value has this term 1 minus 1/4. So this 1 minus 1/4 into h of omega. So this term will be cancelled. Remaining term is 2/1 minus 1/2 e power minus j omega. Okay, e power minus j omega. So 2/1/2, 1 minus 1/2 into 4. What is the value of e power j omega? 4. How we get this one? Put this value is equal to 0. Okay, put this value is equal to 0. Then e power minus j omega is equal to 4. Now this value is minus 2. Now we have this value is 4 and this value is minus 2. Minus 2 or minus 1. Okay, whatever may be. Okay, minus 2. అంటే ఎంత అయింది, ఇది minus 2 అయింది. minus 2 minus 1/2. ఇక్కడ ఇది 2, 1 minus 2 minus 1, minus 2. Okay, minus 2. మిస్టేక్ రాసినాను. ఓకే, హియర్ దిస్ ఇస్ ది ఫార్ములా. ఈ ఫార్ములా గుర్తుపెట్టుకోండి. ఇక్కడ ఏంటంటే, ఇక్కడ ఒక ఇంపార్టెంట్ పాయింట్ ఏంటంటే, ఫర్ ఈచ్ అండ్ ఎవ్రీ చాప్టర్ వీ నీడ్ నాట్ టు ఫాలో ఆల్ ది ఫార్ములాస్. ఓకే, వీ నీడ్ నాట్ టు ఫాలో ఆల్ ది ఫార్ములాస్. ఓన్లీ లిమిటెడ్ నెంబర్ ఆఫ్ ఫార్ములాస్ కెన్ బి యూజ్డ్. దట్ ఫార్ములాస్ ఈజ్ రిటర్న్ ఇన్ ది లాస్ట్ పేజ్ ఆఫ్ ఎవ్రీ యూనిట్. ఓకే, లాస్ట్ పేజ్ ఆఫ్ ఎవ్రీ యూనిట్ లో ఏమైతే ఫార్ములాస్ ఎక్కువగా యూజ్ చేశారో ఆ ఫార్ములాస్ మాత్రం రాశాను, అది మాత్రం ఫాలో అయితే సరిపోతుంది. ఓకే, ఇన్ ఫోరియర్ ట్రాన్స్ఫార్మ్ దిస్ ఇస్ ది మోస్ట్లీ యూజ్డ్ ఫార్ములా. ఈ ఫార్ములా తెలిస్తే చాలు. ఓకే, ఇన్ ఫోరియర్ ట్రాన్స్ఫార్మ్ దిస్ ఇస్ ది మోస్ట్లీ యూజ్డ్ ఫార్ములా. ఇక్కడ ఏదైతే వాల్యూ వస్తుందో ఆ వాల్యూ పవర్ n ఉంటుంది. ఓకే, సో నౌ వీ హ్యావ్ దిస్ వాల్యూ. ఓకే, ఈ వాల్యూ ఒకటేగా, దిస్ వాల్యూ ఈస్ సేమ్. Now in place of a, what is the value? 1 by 2. So 1 by 2 whole power n. According to this formula, 1 by 2 whole power n u of n minus here we have 1 by 4. 1 by 4 whole power n u of n. Okay. ఇక్కడ -2 వస్తే ఇక్కడ -2 వస్తుంది. అప్పుడు ఏమవుతుంది 2 పవర్ n అవుతుంది. అదే -1/2 వచ్చింది అనుకోండి, అప్పుడు ఏమవుతుంది ఇక్కడ -1/2 అవుతుంది. హియర్ వి హావ్ 1/n. ఓకే, ఈ వాల్యూ క్యాలిక్యులేట్ చేయండి. మేబీ మిస్టేక్ ఉందో లేదో చూసుకోండి. ఇక్కడ 2 వస్తే 2 పవర్ n అవుతుంది. ఇక్కడ 1/2 వస్తే 1/2 పవర్ n అవుతుంది. ఓకే, దిస్ ఈస్ ది వాట్ దిస్ వన్ కాల్డ్ impulse response. H of n is called impulse response and H of w is called frequency response. Frequency response ని calculate చేస్తే మనకి impulse response అనేది ఈజీగా వస్తుంది. ఓకే, when we apply frequency response, it is in a if it is H of w, that is frequency response, it is in a Fourier transform. Okay, to make it to normal, we apply inverse Fourier transform. Okay, apply inverse Fourier transform, we will get a H of n, where H of n is called impulse response. Okay, ikkadto ee model complete ayindi. Model 6 is completed. Next, model 7. What is model 7? Here model 7 is called e power minus omega. Okay, model 7 is called e power minus omega. Already we know e power minus omega is equal to, sorry, e power minus infinity. E power minus infinity is equal to 0. Okay, we take e power minus of n plus 1 into t. Okay, while we taking a common, we take a minus as common, compulsory. Okay, if it is minus is not there also, we have to take minus common. Okay, so in place of t, when we put infinity, it will become e power minus infinity. E power minus infinity is 0. Okay, whenever e power minus infinity is 0, problem is very minimized. Okay, problem will be very easy. Okay, so see here, this comes under Fourier transform. Okay, this comes under Fourier transform. So this comes under Fourier transform means it is a model 7. Okay, model 7 comes under Fourier transform, and here unit is 3, unit 3 part 2. Okay, unit 3 part 2. Here model is e power minus infinity is equal to 0. This is the model. Okay, because depending upon this single value, total Fourier transform is dependent. Okay, ఈ యొక్క ఫార్ములా మీద మొత్తం ఫోరియర్ ట్రాన్స్ఫార్మ్ అనేది సింప్లిఫికేషన్ డిపెండ్ అయి ఉంటుంది. ఓకే, టోటల్ సింప్లిఫికేషన్ ఈజ్ డిపెండ్స్ అపాన్ దిస్ సింగిల్ ఫార్ములా. ఓకే, e power minus infinity is equal to 0. Now this is the problem. We have to find a Fourier transform. Okay, we have to find Fourier transform. This Fourier transform is in unit 3 and also unit 4. Okay, in unit 4 it is applications of Fourier transform. In unit 3 part 2, it is just Fourier transform. Okay, in unit 3 part 2, it is just Fourier transform. Okay, whereas in unit 4, it is applications of Fourier transform. Okay, I got another point also, that is discrete Fourier transform. Okay, discrete Fourier transforms belongs to unit 4. Okay, discrete Fourier transform also belongs to unit 4. Okay, that means continuous Fourier transform belongs to unit 3 and discrete Fourier transform belongs to unit 4. Okay, is it clear again? Okay, now next problem. See this problem solution. Already we know that x of t Fourier transform is x of omega. Okay, now what is the regular formula? X of omega Fourier transform formula is integral minus infinity to infinity x of t e power minus j omega t dt. Okay, this is the general formula. This is the general formula in Fourier transform. Okay, so x of omega is Fourier transform of x of t. Okay, this is the general formula. Whatever may be the given x of t, you have to put here or substitute here and do the problem. Okay, already we know what is the formula of cos omega naught t. Okay, what is the formula? E power j omega naught t plus e power minus j omega naught t by 2. Okay, now see here. Okay, this is the formula of cos omega naught t. Here given question is find the Fourier transform of cos omega naught t. So cos omega naught t formula is e power j omega naught t plus e power minus j omega naught t. Okay, by 2. Now into u of t. This is also given omega cos omega naught t into u of t. This is in the question. So in the question you have u of t into e power minus j omega naught t. This is omega t. Okay, here omega naught t. Here we have only omega t. Okay, this is very, very important. Now multiply with this term. Okay, multiply with this term. We have this is the value. Okay, multiply with this term. Okay, before multiplication, we are applying this formula. Okay, u of t. U of t is equal to 1 when t greater than 0. Okay, here limits are minus infinity, infinity. See here, this process is very, very important. Here limits are minus infinity, infinity. Whenever u of t is there, so whenever u of t is equal to 1, t greater than 0. T greater than 0 means minus infinity to infinity is converted to 0 to infinity. Okay, in total Fourier transforms, every time this is applied. Okay, 0 to infinity. Okay, whenever it is u of t, then it is 0 to infinity. Okay, now this is the same value. This t 1 by 2 is taken outside 1 by 2. So e power minus j omega t. This is omega t, not omega naught t. Okay, omega t. Now multiply this value. Multiply this term in both sides. Okay, multiply this term. Here we have this term, and here also we have this term. Okay, separate the integrations also. Separate the integrations also. Now see here, our aim is to take a minus common. Okay, that is the most important point in this model. Take a minus common. So take minus j common. Okay, from these two, take minus j common. Whenever take minus j common, omega. Here take minus is taken common, so minus omega, and t is common here. Okay, so minus j brackets open value and t. Okay, always follow this format only, minus value into t. Okay, whatever may be the value came here, you have to substitute here. Okay, e power minus infinity for that one. Okay, so here take minus common, remaining value into t. So minus, here j also there, so put j also. In some problems minus only is common, and in some problems minus j also is common. So here minus j is there, so minus j and t. Okay, in between we have omega minus omega naught. Okay, here also you take minus j common, so omega plus omega naught. Okay, now apply integration. Minus j omega minus omega naught minus j omega plus omega naught. Okay, now apply limits. What are the limits? 0 to infinity. If it is 0 to infinity, take here minus common compulsory. Okay, if it is minus infinity to 0, no need to take minus common, only plus. Okay, understood? When limits are 0 to infinity, take minus common. Okay, take a minus common. If it is minus infinity to 0, take plus common. Okay, now it is 0 to infinity, take minus common. Okay, so taken minus common, apply limits 0 to infinity. Okay, upper limit is infinity, so e power minus infinity, in place of t put to infinity, so minus infinity. Next e power 0. Okay, next here also e power minus infinity, and okay, e power minus infinity, and the lower limit is e power 0. Okay, already we know what is the value of e power infinity. E power infinity is 0. E power minus infinity. E power minus infinity is 0. E power 0 is 1. So this value is minus of minus plus 1. Here also minus of minus plus 1. These two terms are there. Okay, now see here, whenever this is there, okay, whenever we don't have any value, we have to substitute this value. Okay, whenever you have j omega plus minus omega naught plus omega naught, okay, we have to add this value pi of delta, 2 pi of delta, and omega minus omega naught. Okay, so we have to, in place of plus 0, we have to put these values. Okay, first value is omega minus omega naught, so pi of delta of omega minus omega naught plus pi of omega plus omega naught, omega plus omega naught. Okay, this is for a impulse. Okay, omega delta of means it is impulse. Okay, we have to put a impulse. These cannot be put for each and every problem. Okay, ee term anedi each and every problem pettam, only cos and sine. Okay, whenever it is cos and sine only, we have to put these values. Okay, next, see here, same method, same formula. Now it is sine. Okay, for sine, what is the sine formula? E power j omega naught t minus e power minus j omega naught t into u of t. Okay, substitute in the x of t, you will get this one. Okay, now u of t, whenever u of t, take u of t and put here value 1, and in place of minus infinity infinity, you have to put 0 to infinity. Okay, and multiply these terms. Multiply these terms. Here we have this term, and here we have this term. Okay, now it is 0 to infinity. 0 to infinity, take minus common. Minus j common, omega minus omega naught. Here minus j common, omega plus omega naught. Okay. Now apply integration. Apply integration. This is the value, and apply limits. Okay. Here again, e power minus infinity, that is 0. E power 0, that is minus of minus plus. Here minus of minus plus, and here we have minus. So minus 1 by j omega plus omega naught. Okay, with impulse. Okay, with impulse strength of pi at we have to write this point. Okay, we have to write this point for only for cos and sine only. Okay, here omega minus omega naught, so pi delta of omega minus omega naught. Here omega plus omega naught minus, here we have minus, so minus pi delta of omega plus omega naught. Okay, this is the term. Next problem, sine omega naught. Sine omega naught. See here sine 5t is given into u of t, but for this function, additional function is there, that is e power minus t. Okay, e power minus t function is there. So for this one, we cannot, no need to add this term. Okay, whenever only sine omega naught t u of t and cos omega naught t u of t, you have to add this term. Okay, you have to add this term. But here sine 5t u of t, okay, and we have extra term e power minus t, so no need to add this term. Okay, got it? Okay, next sine 5t. For sine 5t, we have e power j 5t minus e power minus j 5t, e power minus j 5t. Okay, so e power minus t, e power j 5t, e power j omega t. Okay, divide this one. Okay, divide this one and divide this one. Now from these two, take a minus common. Why we are taking minus common? To apply e power minus infinity, that is 0 to infinity, you have to take minus common. So take minus common and t, put t here. Okay, minus here and t here. What are the remaining terms? Here minus is there, minus is taken common, t is taken common. So 1 plus, from these two, j common, j, omega minus already taken, so omega minus 5, omega minus 5. Here also minus t common, minus t, put here t, and here 1 plus j common, omega plus 5. Okay. Now here apply integration 0 to infinity, apply upper limit and lower limit. E power infinity is 0, minus e power 0, minus of minus plus and 1. See here, minus of minus plus and here minus, so minus. Okay, here we have 1 plus j of omega minus 5, 1 plus j of omega plus 5. Take LCM, we have j 10 by 1 plus j omega square plus 5 square. Okay, so here neglecting impulse, that is extra term. Okay, previously we added a extra term, so here we can neglect a impulse term. Okay, next, e power minus 2t cos 5t plus omega u of t. If it is cos 5t u of t, you have to add impulse term, but here we have another term, e power minus 2t, so neglect a impulse term. Okay, so here e power j 5t, e power j 5t plus e power minus j 5t by 2 u of t. Okay, this is the formula. Substitute in this formula. So substitute in this formula. This is the value and this is the value here, and the e power minus j omega. When our minus infinity u of t is there, we have to change these limits from 0 to infinity. 0 to infinity. Okay, 0 to infinity. 2 is there. Take outside 1 by 2. So in this term, we have to take minus common. In this term, we have to take minus common and put this t here. Okay, now 2 plus in this 2 j omega, j common, omega minus 5, omega minus 5. Here it is omega minus 5, it is omega plus 5. Okay, apply. Okay, apply integration. After apply integration, you have to apply lower limit and upper limit. Lower limit and upper limit. Okay, lower limit is infinity, that is e power minus infinity is 0, minus of minus plus, this is 1 by this value, and minus of minus plus and this value. Okay, and take LCM, this is the value, and here also neglect a impulse function. Okay, like this Fourier transform is there. Next, see here, this is very important formula in this Fourier transform. Okay, this is very important formula, very important problem. Same method, no change. Okay, same method, but here only difference is e power minus modulus of t. Modulus of t means this t is a positive or negative. Okay, so whenever we put e power minus modulus of t, this t may be plus t, or this t may be minus t. So e power minus, when it is t greater than 0, when t greater than 0 means positive, so e power t. This is the equation. When t less than 0, okay, when it is t less than 0, t is minus, so e power minus of minus t, that is e power t. So whenever t greater than 0, value is e power minus t. Whenever t less than 0, value is e power t. Okay, you have to write this function. So x of t is equal to e power minus t. E power minus t is equal to e power minus t. Okay, write like this: e power minus t, e power t. Okay, comma, when t greater than 0, when t less than 0. Okay. Okay, like this you have to write. Here modulus of t means t may be greater than 0 and t may be less than 0. When t greater than 0, e power minus t. When t less than 0 means minus. Minus of minus plus t. Okay, so 2. Now divide, see here, minus t plus t. Okay, but here limits are given. What are the limits? Minus 2 to 2. Okay, now limits minus infinity changes to these limits. Remember one important point, whenever in question limits are given, these limits automatically changes to these limits. Okay. So this is the shortcut method. Already limits are given. You have to put these limits. Okay. -2 to -2 to 2. So here this is less than 0. This is greater than 0. Less than 0 means -2 to 0. Okay. Greater than 0 means 0 to 2. Okay. Now -2 to 0. -2 to 0. Already we know it is 0 to infinity. Take minus common. If it is minus infinity to 0, take plus common. Okay. Already we know. That is the our model. So here minus infinity to 0. That is -2 to 0. Okay. -2 to 0 means you have to take plus common. Next 0 to 2. That is it is like a 0 to infinity. 0 to infinity means it is minus taken. Okay. So for 0 to 2, you have to take minus common. In this minus common, put t here, remaining term 1 plus j omega, 1 plus j omega. Here take plus common and t here, and value is 1 minus j omega. Okay. Apply integration and apply the limits. Okay. Apply the limits. Now we have e power 0 minus e power minus 2. Okay. Now this is the value. This is the value, and separate these values, you will get like this terms. Okay. Now these two, e power j2 omega, e power j2 omega. Okay. E power j omega, e power 2j omega. Take this term and this term. Okay. This is converted to cos 2 omega. Okay. Here omega is there. Take omega. And here we take here also maybe omega. Okay. Here also maybe omega. So take omega common. This is e power j omega minus e power j omega. This is sin omega. Okay. This is very, very important problem. Okay. E power minus modulus of t. Find the Fourier transform of e power minus modulus of t between the limits -2 to 2. Okay. These limits may be changed in a given exam. That is -1 to 1 or -3 to 3 or -4 to 4. Whatever may be. Okay. So that you have to put that limits here. Okay. Venara?
Yes, sir.
Okay. Next one is same model, example 3. Okay. Now we are at a same model, that is model number 7. Okay. Same model number 7. Okay. And e power minus infinity. This model is e power minus infinity model. Okay. And this unit belongs to unit 3 part 2. Okay. Unit 3 part 2. Here equation is given. Okay. Here equation is given. Now here signal is given. Signal waveform is given. So whenever signal waveform is given, how we can find Fourier transform, and we have to draw the spectrum. Okay. Here what is called spectrum. Okay. Spectrum means simply graph. Okay. Here we have two types of graphs, two types of spectrums: amplitude spectrum and a phase spectrum. Amplitude spectrum means only magnitude. Phase spectrum means only angle. Okay. Spectrum means it is a graph. Okay. We have two types of graphs: amplitude spectrum and phase spectrum. Amplitude spectrum means only we take a magnitude value only. Phase spectrum means only we have a angle only, that is theta. Okay. We have only theta value. Okay. Now see here, magnitude means modulus of h of omega. Here angle means h of omega angle. Okay. H of omega modulus. Okay. Now find the Fourier transform. First you have to find the Fourier transform. Okay. Method is same method. Same method, but here one of the important point is whenever you have two e power thetas. Okay. Here it is e power plus j omega. Here it is e power minus j omega. Okay. Plus j omega minus j omega. If we have if you have here minus, it will be sine omega t. If you have plus, it becomes cos. If it is 2j minus and 2j minus and 2j, it is sine omega t. Plus and 2, it is cos omega t. But here, see here, in this conversion, we have only one e power term only. Okay, whenever we have one e power term, how we can convert these terms into two e power terms, and then we have to convert into sine or cos, and later it is converted into sinc data. Why you are converting these equation into sinc data? Because already sinc data is the standard signal. Okay, sinc function is the standard signal. So maximum possibility in Fourier transform, each and every final equation should be converted into sinc data. Maximum. Okay, 90% we have to convert it into sinc data. Okay, sinc function. Okay, what is the waveform? At 0, it is maximum value and is gradually decreasing. Okay, it is gradually decreasing. That is the one sinc equation. And another sinc waveform is same equation, same waveform, but it decreases the value and find one amplitude. Okay, that same amplitude is maintained. Okay, this is maximum. It is decreases to some value, and that value is maintained. Okay, this cannot be gradually decreased. That is the second one. Okay, one is gradually decreasing and becomes 0, and second one is decreases to some value and maintain that value. These are the two types of sinc functions. Okay, here we got a standard sinc function, that is constant sinc function. Constant sinc function means it is decreases to some value and maintain that value constantly. Okay, ఈ పాయింట్ అర్థమైందా? సింక్ ఫంక్షన్స్ టూ టైప్స్ ఉంటాయి. ఓకే, ఒకటేమో గ్రాడ్యువల్ గా డిక్రీజ్ అయిపోతుంటుంది, 0 అయిపోతుంది. ఓకే, అది గ్రాఫ్ గీస్తాను చూడండి. One sinc function is gradually decreasing. This one, okay, gradually decreases and becomes 0. Another sinc function is maintain some value. Another sinc function is maintain some value and constant that value. This value is constant. Okay, these are the two types of sinc functions. Okay, next, ఆల్రెడీ మనకు ఒక వాల్యూ తెలుసు, ఏంటది? 1 plus x. ఓకే, ఎగ్జాంపుల్ 1 plus x. Now I want to make these two terms as a x value. How we can make these two as a x value? ఎలా కన్వర్ట్ చేస్తాం చెప్పండి? ఎలా కన్వర్షన్ చేస్తాం? 1 plus root x into root x కదా. Take root x common. Now 1 by root x plus root x. Okay, now root x into x power minus 1 by 2 కింద రాయొచ్చా దీన్ని? మైనస్ ప్లస్ x power 1 by 2. Now we have two terms as a x terms. Here we have only one term as a x term and another term is not x term. So to make it both x terms, we have to take one root x common. Okay, so x power 1 is converted to x power 1 by 2. If it is x power 1 by 2, it is converted to x power 1 by 4. X power 1 by 4. Okay, if it is x power 1 by 4, it should be converted into x power 1 by 8. Okay, got this point? Okay, so that is applied here. Okay, this concept is applied here. Okay, here we
Yes,
have only one term. E power j theta has only one term. Okay, whenever we have both terms, when we have both terms only, we can convert into either sin omega t or cos omega t. Whenever we convert into sin omega t, we can convert into sinc theta. What is the formula of sinc theta? What is the formula of sinc theta? Sin theta by theta. Okay, so in Fourier transform, final equation should be converted into sinc theta. 90% of equations are converted into sinc theta. That is, this function is converted into 2e power terms. Whenever 2e power terms are there, it is converted into sin omega t or cos omega t. Whenever it is sin omega t, it is converted into sinc theta. We know that sinc theta is sin theta by theta. Okay, now we are going to follow this process. Okay, in this problem, now we are going to follow this process. Okay, now see here. Already we have function x of t. We have x of t function 0 to t. 0 to t, what is the value? A. So a. Okay, before 0 to t and after 0 to t, value is 0. So 0 for others. Okay, this is the function. Put this function, this is the Fourier transform general formula. Okay, put this value in the general formula. What are the limits? 0 to t. Okay, so limits are 0 to t. Minus infinity infinity, limits are changes to 0 to t. Why? Because we here we have signal from 0 to t only. So limits are 0 to t. What is the x of t value? A. Put a value, e power minus j omega t, e power minus j omega t dt. Okay, next you take a common and find the integration. Okay, this is the integration. After applying limits, we have this is the value. Okay, but we want both values as e power j omega. Okay, we have e power j omega. Next term is e power minus j omega, or this is e power minus j omega or e power j omega. That means both terms should be in e power j omega. Okay, so we don't have second expression as the e power j omega. So to make it j omega, here what is the value? Omega t. Okay, these omega t, whenever we are taking common, okay, common, 1 is converted to 1 by 2. Okay, 1 is converted to 1 by 2. So using this formula, okay, we take j omega. See here, we take minus j omega by 2. Minus j omega by 2 as common. Okay, omega tau by 2 is common. What is the remaining term here? E power j omega by 2. Okay, minus here no term is there. No term is there, but we take a term common. So it is minus. Okay, minus of minus. So for this one, this is the term, and for this one, this is the term. Okay, so take this value common. Take this value common. Okay, maybe mistake written mistake is there. Here it is minus, here it is plus. Okay, here it is minus, here it is plus. Whatever may somewhat mistake is there. So e power minus j omega t, e power minus j omega t by 2. Here also omega t by 2. Okay, here it is minus j omega by 2, because denominator term comes to numerator. See here, denominator term comes to numerator. This will become x power minus 1 by 2. X power minus 1 by 2. So here x power minus 1 by 2, this become positive. Okay, so this term e power j omega 2 by 2 minus e power minus j omega 2 by 2. Okay, ఈ పాయింట్ అర్థమైందా?
Yes, sir.
Okay, next, after taking minus common, this is in the which form? Sin omega t form or cos omega t form?
సార్
చెప్పండి.
అది మామూలుగా మనకి సిగ్నల్ ఇచ్చి జస్ట్ ఇలా కనిపెట్టుకోమంటాడు.
సిగ్నల్ ఇస్తాడు అంతే, ఫార్ములా ప్రకారం వెళ్ళిపోవడమే.
ఓకే సార్.
ఓకే, e power j theta minus e power minus j theta అంటే అది సైనా కాసా? రెండు మైనస్లు వస్తే మైనస్లో ఇక్కడ మైనస్ వచ్చి ఇక్కడ j వస్తే దట్ ఈస్ సైన్. ఇక్కడ ప్లస్ వచ్చి ఇక్కడ 2 వస్తే దట్ ఈస్ కాస్. సో దిస్ ఫార్ములా ఈస్ కన్వర్టెడ్ టు omega. Take this omega to here. So a by omega, okay, a by omega, there is no 2. So multiply and divide with 2. Multiply and divide with 2. Denominator is 2. Numerator is 2. Okay. Here 2. Here 2. Next. This formula is sin omega t by 2. Omega tau. This is tau. Omega tau by 2. Okay. Now, whenever you got sin theta, it can be converted into sec theta. Okay. What is the formula of sec theta? Sin theta by theta. So whatever may be the theta here, that value should be here. Okay, we have to arrange that value. Okay, so that to arrange this value, what is the value? Omega tau by 2. Okay, so write directly here omega tau by 2. Okay, what is the remaining? This omega is written here, these 2 is written here. So what is the extra value you needed? Tau value. So multiply and divide with tau. Okay, multiply and divide with tau. So here a tau. This is in the form of sin theta by theta. Sin theta by theta is sec theta. So it is sec, okay, sin c, sec omega tau by 2. Okay, so at. This is called amplitude. Okay, this coefficient is called amplitude. So with this amplitude we can draw the amplitude or magnetic spectrum. Okay, omega tau by 2 is called angle. So you can write a phase spectrum. Okay, question lo vadu adigaru anukondi. Okay, write the amplitude spectrum. You have to draw this amplitude spectrum using this coefficient value. Okay, so amplitude spectrum. Okay, put t is equal to 0. Put omega. Okay, this is omega value. This x-axis is omega value. So put in this value, in this total value, put omega is equal to 0. E power 0 is 1. Here there is no omega value, so a tau. Okay, so this is a tau. Next, put omega is equal to 1. Okay, put omega is equal to 1. This becomes a 2 pi by tau. Okay, 2 pi by tau, 4 pi by tau, 6 pi by tau. Okay, this is omega value. This is not the first. Put omega is equal to 0. Next, put omega 2 pi by tau, 4 pi by tau, 6 pi by tau. This is x value. Okay, ante x is equal to 1, 2, 3, 4 ala untundi kada. Same here also we have omega is equal to 2 pi by tau, 4 pi by tau, 6 pi by tau, 8 pi by tau. Okay, now here we have maximum value. Next, this tau is constant and a is constant. Tau is constant and a is constant. So there is no vary. So there is no vary. This maximum value reaches to some value and maintain this constant value. Okay, suppose you have any variable value, then it gradually decreases. Okay, so here we have only constant value. So it comes to some constant value and maintain that constant value. Okay, aithe ikkada question entante, here question is why we are taking omega value as a 2 pi by tau, 4 pi by tau, 6 pi by tau instead of 1, 2, 3, 4. ఎందుకు తీసుకుంటున్నాం? Why you are taking that? Because we have omega is equal to 2 pi by t. Already we have the formula now. Omega is equal to 2 pi by t. Okay, so this is the 2 pi by t. That is, this is called omega is equal to 1. If omega is equal to 2, 2 into 2 pi by t, 4 pi by t. It is 3. So 3 into 2 pi by t, 6 pi by t. 3 into 4, this one. Okay, got it? Okay. Now this is completed. We are in model 7. This model 7 is almost completed. Next is some important problems. Okay, in Fourier transform, important problems. See here, important problems. Find the impulse response is given, h of tau. Find the response of the system. Here, response of the system is y of t. Okay, that is output, total output. Input is given. Okay, so using Fourier transform. Okay, this question can be asked in second unit, fourth unit. Okay, ante impulse response అనేది సెకండ్ యూనిట్ లో ఉంటుంది అండ్ ఫోర్త్ యూనిట్ లో ఉంటుంది. అంటే మోస్ట్ ప్రాబబ్లీ important topics in units is second unit and fourth unit. Okay, second unit is directly, that is normal method. In fourth unit is Fourier transform. Okay, got it? Impulse response is the question given in second unit and fourth unit. Okay, in second unit he will ask directly find the response. In fourth unit he will ask using Fourier transform. Okay, so now what are the main points here? Y of omega by x of omega is equal to h of omega. Next, y of t by x of t is equal to h of t. దీన్ని మనం ఏమంటాం అంటే this is called transfer function. This is called transfer function, and this one is called this is called frequency response. This is called frequency response. Okay, now this is called this is no name, that is h of t. Here h of t is called impulse response. H of t is called impulse response. H of t is called impulse response. So here what is given? H of t is given. So here h of t, y of t, x of t. H of t is given. Okay, h of t is given. Next, what is given? X of t is given. So x of t is given. What is not given? Y of t. Okay, this y of t is called a response system for the input. So we have to find y of t. Okay, y of t. For that one, first we calculate h of omega and x of omega in Fourier transform. Okay, in which form we are calculating? In Fourier transform we are calculating h of omega and x of omega and calculate y of omega. From y of omega we will calculate y of t. Okay, this is the easiest method. Okay, to find the impulse response, this is the easiest method. Second unit is somewhat difficult, somewhat lengthy process, but here second unit and fourth unit. Okay, second unit is tough, this is hard. Second unit is hard, and fourth unit same question is easy. Okay, when we apply Fourier transform, here we apply general method. Okay, standard method. Here we apply general standard method. Here it is very easy in fourth unit because we apply Fourier transform. Okay, see here in second unit almost this type of problem takes 2 to 3 pages. 2 to 3 pages. Okay, whereas in this we have only 1 page. This answer is only 1 page. Okay, so this is very, very important and easy question. Okay, in fourth unit. This will be asked in a fourth unit. Okay. Okay. Now h of w. Okay, x of t. X of t is converted into Fourier transform. X of t is converted into Fourier transform. Okay. Now I forgot to tell one important point that this is the most important formula used in Fourier transform. E power minus at Fourier transform. Okay, Fourier transform is 1 by 1 by j omega plus a. This is very, very important. Almost this formula is used in third unit and fourth unit. Okay, this single formula, only this single formula is used in total fourth unit and third unit. Okay, once wait, I will recheck that one. Third unit part 2. Third unit part 2. Okay. Third unit part 2 same. This formula only, and fourth unit. In fourth unit also almost yes, this formula. Okay. In fourth unit and third unit, this Fourier transform formula is used. Very, very important. Almost 90% of problems has only this formula. Okay. Only this formula. Another formula is there. Another formula, that is 1 by 1 minus a e power minus j omega. Already we saw this formula. Here, whatever may be the value that comes under here, a power n u of n. Already we see this formula. If a is equal to 1 by 2, here a is 1 by 2. If a is equal to 2, here a is equal to 2. This is also very, very important formula. Okay. So this is very, very important formula. In Fourier transform, almost 90% of the problems has same formula. Okay, e power minus at. Okay, Fourier transform is 1 by j omega plus a. Here we have minus a, it has plus a. It is plus a minus a. Okay, if a has minus 2, here plus 2. It is minus 3 plus 3, minus 4 plus 4, minus 5 plus 5. Now it is plus 2, minus 2, plus 2, minus 2, plus 3, minus 3, plus 4, minus 4. Okay. Now see here. Now we are taking these time domain to Fourier transform. That is frequency domain. So x of t is time domain taken to frequency domain. 2 into e power minus 5t u of t. U of t is common. Okay. U of t is common term. No problem. Neglect that one. Okay. So e power minus 5t minus 5t. Minus 5 means plus 5. Okay. It is 3. I think it is 3. Okay. Minus 3. Minus 3 plus 3. Okay. 2 by j omega. Fourier transform is j omega. So j omega plus 3. Okay. Now, okay. See, some mistake here. This one. Okay. This is x of omega. That is h of omega. H of t, h of omega. Okay. This is this for this formula. This is the answer. For this formula, this is the answer. Okay. For 2 e power minus 3. Minus 3 means plus 3. Okay. 2 by j omega minus 3 plus 3. Here 2 minus 5 j omega plus 5. So we have h of omega and x of omega. Okay. We have h of omega and x of omega. We want y of omega. So y of omega is equal to h of omega into x of omega. Okay. So now y of omega is equal to h of omega into h of x of omega into h of omega. Now 2 by j omega plus 5 into 2 by j omega plus 3. Okay. Now go for the partial fractions. Okay. Partial fractions, a is equal to, hide this term. Okay. Suppose a is equal to, suppose a by j omega. See here, a by j omega plus 5, b by j omega plus 3. To calculate a value, we have to substitute minus 5. To calculate b value, we have to substitute minus 3. So here j omega plus 5, hide this term. So hide this term, 4 by j omega plus 3. 4 by, what is the value of j omega? For a value, minus 5. So j omega minus 5 plus 3, that is minus 2. And for b value, put j omega is equal to minus 3. J omega is equal to minus 3. Okay. So b is equal to 4 by minus 3 plus 5, that is 2. So b value 2. Okay. Partial fractions. Next, y of t is equal to minus 2. Now what is the inverse transform? Okay. Fourier transform. Previously, we have gone from left to right, Fourier transform. For inverse Fourier transform, from right to left, simple. Okay, right to left. Here it is plus a minus a. So here plus 5 minus 5. Okay, minus 2. Okay, plus 5 minus 5. U of t is compulsory. Plus 2 e power minus 3t u of t plus 3 minus t. Okay, take u of t common. This is the answer. Okay, simple. First is using this formula left to right, and last using this formula right to left. Right to left is inverse Fourier transform. Okay. Next. Now it is inverse Fourier transform value is given. We have to calculate inverse Fourier transform. You have to calculate inverse Fourier transform only. This is also one of the important question. Here already Fourier transform is calculated and this value is given. So you have to calculate inverse Fourier transform. Okay, very easy. Just apply formula. So j omega means Fourier transform. Okay, for this one apply partial fractions. Okay, apply partial fractions. For a value, put j omega is equal to minus 2. So put j omega is equal to minus 2. Okay, put j omega minus 2, value is minus 1. Okay, how we can get this value? You have to hide this term. Okay, in this dot, this is the main equation. So in this equation, for a value, you have to hide this term. See here, hide this term. What is the remaining value? Remaining term 4 j omega plus 6 by j omega plus 4. So here put j omega is equal to minus 2, minus 2, minus 2. See here, minus 2, minus 2. Okay, so a is equal to minus 1. Next, put j omega is equal to minus 4. J omega is equal to minus 4 for b value. Okay, now hide this term. Hide this term. So this value here minus 4, minus 4, minus 4, minus 4. Value is 5. So you will get a here b value. Okay. Now you have minus 1 j omega plus 2 plus 5 by j omega plus 3. Now using formula. Already we have one formula. What is the formula? What is the formula? E power minus at u of t Fourier transform is sorry. Fourier transform is 1 by j omega plus a. Fourier transform. When you are from right side to left side, it is inverse Fourier transform. Okay. Now see here, already it is in Fourier transform. Apply inverse Fourier transform. Apply inverse Fourier transform. Same formula. Okay. Last formula. Same formula. In place of a, we have 2. So e power minus 2. E power minus 2 into u of t. In place of a, here we have 4. So e power minus 4. Simple. Okay. Now see here, for this one, partial fractions, when it is a j omega plus 3 square. Square means you have to write 2 times. If it is cube, write another time. C by j omega plus 3 whole cube. Okay. So substitute this value to 0. Okay. To have b value, you have to substitute this value to 0. So j omega plus 3 whole cube whole square is equal to 0. So put j omega is equal to minus 3 to find the value of b. Okay. Find the value of b. Okay. In this term, you have to put b is equal to j omega is equal to minus 3. Okay. So here, note hide this term. What is the remaining term? 1 plus j omega. Put j omega is equal to minus 3. Okay. Minus 3. So minus 3 into 3, minus 9, minus 9, minus 8. So it is minus 8. Next, for this one, put j omega is equal to 0. J omega is equal to 0. Okay. J omega is equal to 0 for the total term. Okay. For the total term. So this term is equal to this term. So for this total term, okay, for this total term, we have to put a j omega is equal to 0. So 1 plus 3 into 0, 0 plus 3 whole square is equal to a by, okay, a by 0 plus 3. 0 plus 3 minus 8 by 0 plus 3 square. Okay, already we know the value of b. Put the value here. Okay, so now calculate this value. Okay, you get a is equal to 3. Okay, now 3, a is equal to 3, b is equal to minus 8. Now apply same formula. In place of a, we have 3, so it is e power minus 3. In place of 3, we have 3. Suppose so e power minus 3. It is square. Okay, if it is square, it is t. If it is cube, t square. Okay, so it is square 2 minus 1, t power 1. If it is cube, then it is called 3 minus 1, 2. That like, okay, extra t will be there. This is rarely used. Okay, the second important formula is this one. Second important formula. Okay, like that. This you have to calculate. These are the some important questions in Fourier transform. Okay, in Fourier transform, important questions. This one also important question in Fourier transform. That is unit 3, part 2. Unit 3, part 2. Okay. Next, model number 8. Okay, I forgot to record off and on. Okay, I will continue like this only. Okay, no problem. Next is model number 8. What is model number 8? Model number 8 is frequency response. Okay, model number 8 is frequency response. This is comes under unit 4. This comes under unit 4. Unit 4, frequency response. This is the most important and expected question from unit 4. Okay, if it is not there, next important question is discrete Fourier transform. Okay, next one is discrete Fourier transform. These are the two important questions. Okay, already we know what is the frequency response. Frequency response is h of omega. That means this also indirectly problem is impulse response. Here also we have to calculate a impulse response. Okay, already we discussed that in unit 2, important question is impulse response. Okay, but here used method is general method. We use method here, general method. Okay, but here unit 4, impulse response. Okay, before impulse response means h of t. Before impulse response, it is called a frequency response. That is h of omega. Already we write the formula. H of omega is equal to y of omega by x of omega. Okay, this is frequency response. Okay, now h of t is equal to y of t by x of t. Okay, this is called impulse response. Okay, if you remember these two formulas, we can attempt unit 4 and unit 2 also. Okay, now another important question is discrete Fourier transform. If it is not given, if we are in one set it is not given, it will give discrete Fourier transform. Okay, next, now our model 8 is completely on frequency response. Okay, frequency response means it is a unit 4. It belongs to unit 4. Unit 4 is applications of Fourier transform. Unit 4, applications of Fourier transform. Now see here, first example. These examples are very, very important. In these examples only, okay, in these examples we can cover partial fractions also. Partial fractions. Okay. A by j omega plus 2, b by j omega plus 3, like that. Okay. Here already given. Consider a casual LTI system with the frequency response. Okay, frequency response is given, that is h of omega. Already we know frequency response means h of omega. H of omega is equal to 1 by 4 plus j omega for a particular input. Okay, for a particular input, the system is observed to produce the output. So here output is given. Okay, output is given. We have to find input. Okay, already we know what is the formula. H of omega is equal to y of omega by x of omega. Okay, so here h of omega is given, y of t. Okay, y of t is given, y of t is given. Okay, x of t, h of t. So y of t is given. This is converted to y of omega. Okay, y of omega, and we have calculated x of omega. From x of omega, we are calculating x of t. Okay, whatever may be the questions given, it is converted to frequency response. That's it. Okay, that's it. That is we are converting to frequency response. Frequency response means Fourier transform is applied. After Fourier transform is applied, inverse Fourier transform is applied, and find h of t or y of t or x of t. Okay, so h of omega is already in Fourier transform only. Okay, already in a Fourier transform, that is frequency response only. Already we know h of w is frequency response, or it is called transfer function. Okay, now output is given in terms of time domain. It is converted to frequency domain. Frequency already we know e power minus 2t u of t. See here also same formula. Okay, what is the formula? E power minus at u of t is Fourier transform is 1 by j omega plus a. Same formula. See here, already we discussed two formulas, two problems. In two problems also same formula. Okay, that is forward is Fourier transform, reverse is inverse Fourier transform. Okay, so Fourier transform of e power minus 2t u of t, e power minus t u of t, in place of a it is 2. So what is the formula? 1 by j omega plus 2. Okay, 1 by j omega plus 2. Next here 4. So 1 by j omega plus 4. Next here I did directly this value is there. Now apply LCM. Okay, apply LCM. This is the value. Okay, so y of omega is obtained. Already we know that h of omega is equal to y of omega by h of omega. What the value we have to know? Already right here formula. Okay, formula like this you have to write every time formula. Okay, that is very, very important. Okay, so what you have to find here? X of omega. So take this x of omega to here and h of omega to here. This is the value, and substitute these two values. This is the value. Okay, 4 plus j omega get cancelled. 2 by 2 plus j omega is there. Apply inverse Fourier transform. Okay, apply inverse Fourier transform. What is the inverse Fourier transform? See here, inverse Fourier transform. Forward means Fourier transform. Reverse means inverse Fourier transform. What is the value here? Plus 2. Plus 2 means minus 2. Okay, minus 2. So 2 into e power minus 2t u of t. U of t is common here. So x of t, this is the value. Okay. Next, main in this one, main is h of omega. Finding h of omega, and finding later h of t. When h of omega is found, when we apply inverse Fourier transform, okay, h of t is obtained. These formula or this problem is very, very important. Okay, here we find h of x of omega. This is somewhat okay. but finding h of omega problems are very, very important. Okay. So next problem. Next problem. In this problem, one circuit is given. The impulse response of the continuous time system is expressed as, okay, h of t is given. Find the frequency response. What is frequency response? H of w. Okay. So whenever apply Fourier transform this to this value, this h of t, it is h of w. That is the frequency response. Okay. Now, after getting frequency response, you have to plot the frequency response. Okay. For frequency response, there are two types of plots. One is magnitude plot, and second one is phase response or phase plot. Okay. Magnitude response, that is magnitude plot, or and phase plot. Okay. So these two are the plots. This belongs to only with the magnitude. Okay. That is the coefficient, and this belongs to only theta, that is only angle. Okay. So here this is the value given. Now apply Fourier transform. It is also in the form of e power minus t. Here what is the value of a? E power minus at. Now what is the value of a? A is equal to 1 by RC. Okay. Here a is equal to, see here I write in the form minus at. Okay. So here value a is 1 by RC. Now according to formula, what is the value? 1 by RC into 1 by j omega plus a. 1 by j omega plus a. In place of a minus a, it is plus a. 1 by RC. In place of a 1 by RC, here we have 1 by RC. Okay. So now take the LCM, and cancel this one. We have 1 by 1 plus j omega RC. From this one, now we have to find the magnitude plot. Okay. So for this one, magnitude is 1 by a square plus b square. So 1 by a square 1 square plus this is a plus jb. A plus jb means a square plus b square. So 1 square plus omega RC square. This is magnitude. Next, phase response, that is only angle. For this one, angle is tan inverse b by a. Okay, tan inverse b by a. It is a, if it is in numerator, tan inverse b by a. If it is denominator, minus tan inverse, it will come to numerator, that is minus. So minus tan inverse b by a. B is omega RC, imaginary value. Next, real value is 1. Okay. So to plot the frequency response, put RC is equal to 1. Put RC is equal to 1. So in magnitude, RC is equal to 1 plus omega square. So 1 plus omega, 1 by 1 plus omega square plot is this one. Okay. These type of waveforms are called Gaussian. Okay. Gaussian waveforms. Next, this is the tan inverse. Already we know tan. It is between the limits of pi by 2 and pi by 2. Okay. Limits are between pi by 2 and pi by 2. So this is the graph of tan. Okay. These type of problems are very, very important because here given h of t, and we have to find frequency response. Frequency response means h of omega. So finding h of omega, that is frequency response. Okay, that is very, very important problems. Next, third one. Example 3. In example 3, here also f of t is given, y of omega is given. Already we know e power minus at formula is Fourier transform is 1 by a plus j omega. Already we know. So here, what is the given value? Output is given. Okay, output is given. Find the transfer function. What is the transfer function formula? Output by input. Okay, transfer function formula is output by input. So here f of t is input. F of t is input. So we have to find Fourier transform of this one, and the output is there. So output by input gives the transfer function. Okay. Already we know transfer function is the frequency response. Frequency response means h of omega. Okay. So h of omega is there. So whenever you got h of omega, we can find a impulse response. Okay. How we can find impulse response? H of omega, apply inverse Fourier transform. for h of omega, apply inverse Fourier transform, we will get a impulse response. See here, I will write here h of omega. H of omega is equal to y of omega by x of omega. These h of omega is called a transfer function, or it is called a frequency response. Frequency response. Okay. So h of omega generally it is called frequency response, or it is called transfer function. Okay. Now h of t. H of t is called impulse response. Impulse response. So h of omega, whenever for h of omega, if we apply inverse Fourier transform, we will get h of t. Okay. So apply Fourier transform for input. F of t is the input here, already given in the diagram. F of t is the input. So for f of t, apply Fourier transform. Apply Fourier transform. Already we know here formula e power minus at into u of t. Here u of t is not given. We can put e of t. So 1 by j omega plus a. Here minus means plus. So 1 by j omega plus a. Okay. We don't know the value of a. Now h of t, transfer function is equal to h of omega, or this transfer function is also called frequency response. So frequency response h of omega is equal to y of omega by f of omega. That is this one. This is 1. Okay. H of omega is equal to 1. Already we know inverse Fourier transform of h of omega is delta of t. Okay. So it is impulse function delta of t. Simple. Okay. Next. These are also simple. 9 and 10. 9 and 10. So here find the difference equation. What he told? Difference equation. What is the difference between difference equation and differential equation? Difference equation belongs to discrete waveform. Differential equation belongs to continuous waveform. So here discrete waveforms are given. Okay, discrete equation is given. So in discrete equation, what do we have? Y of n, y of n minus 1, y of n minus 2. N minus 2 means second order difference equation. See here, j minus j 2 omega minus j 2 omega means second order difference equation. Okay, here y of n minus 2 means second order difference equation. Okay, so here already Fourier transform is given. Fourier transform x of omega is given. Okay, so we have to find the difference equation that characterized by the system whose frequency response is given. Okay, here see here x of omega means input generally, but here given frequency response. So frequency response means this can be taken as h of omega only. Okay, to confuse you, this is the given. So x of omega means it is not x of omega, it is h of omega, because here x of omega is mentioned as a frequency response. Already we know frequency response means h of omega. Okay, so y of omega by, already we know h of omega is y of omega x of omega. This substitute here and cross multiply. Okay, cross multiply, we obtain this value. Okay, y of omega plus 1 by 3 e power j omega. Okay, now we have one formula. Okay, this is the second most important. Okay, see here, in continuous important formula is e power minus at u of t Fourier transform 1 by j omega plus a. Okay, in discrete most important formula is Fourier transform of y of n minus 1 is e power minus j omega into y of omega. This is Fourier transform. This is inverse Fourier transform. Okay, this is Fourier transform, and while going this direction, this is inverse Fourier transform. Okay, see here, now we discuss about 4 to 5 problems, but in every problem, this is the main formula. Okay, now only we have this formula. So in Fourier transform, that is in third unit or fourth unit, almost 99% is these two formulas only. Okay, no need to study other formulas. You have to study these two formulas only. Okay, so now see here, what is the formula? Y of n minus 1. If it is minus 1 minus j, if it is minus 2 minus, it is minus 2 minus j 2 omega. If it is minus 3 minus j 3 omega. Okay, already we are at here. See here, we are at here. So from here to here, that is here to here, that is inverse Fourier transform. Okay, apply inverse Fourier transform. Okay, here it is inverse Fourier transform, not Fourier transform, it is inverse Fourier transform for y of omega, y of n plus 1 by 3. Here it is minus 1, so y of n minus 1. Here it is minus 2, so y of n minus 2. Here y x of omega, x of n minus, here minus 1, x of n minus 1. Here minus 2, so n minus 2. Completed. Okay, this is the difference equation, second order difference equation. You can write this is the second order difference equation. Okay, next problem, find the frequency response. Okay, find the frequency response of the following causal system. Already first problem is given in the mid to important questions. Okay, mid to important questions, and in material page number 6. Okay, mid to important questions, separate material. In this material page number 6, this question and answer will be there. Okay, now second one. Okay, see here, I write here clearly. This answer is given in mid to important questions and answers, material page number 6. Okay, next, second question is given. Here already difference equation is given. Now we have to find a frequency response. Okay, these type of problems are very, very important. Okay, these type of problems are very, very important. This is very, very important. Okay, finding frequency response. Okay, finding frequency response or h of t. Finding frequency response or h of t. After frequency response only we can find h of t. Okay, so finding frequency response problems are very, very important. This is very, very important problem. Okay, already maybe in last but one, that is 2023, this problem is given, this type of problem is given. Okay, next, for this question take Fourier transform on both sides. Okay, already we have this formula. See here, again we are using this formula only. That means in discrete this is the main formula, and for continuous this is the main formula. If you know these two formulas, you can write third unit and fourth unit problems. Okay, so here minus 1 means minus j, minus 2 means minus 2j omega, minus 3 means minus j 3 omega. Okay, now see here, y omega, yn means y omega, minus 1 by 4, n minus 1, minus 1, so e power minus j omega, minus 3 by 8, minus 3 by 8, n minus 2, so 2, e power minus 2j omega. Okay, x of n, x of w, n minus 1. Okay, so e power minus j omega. Okay, take x of w common, here y of w common. Okay, so we want first of all we have to form y of omega by x of omega. So it is h of omega. Okay, h of omega is transfer function or frequency response. So here we have h of omega. Next, okay, what he asked? Okay, he asked about only frequency response only. Okay, he asked only frequency response. So h of omega is the frequency response. So this is the answer. No problem. Okay. If he ask h of t, that is impulse response. If he ask impulse response, then you have to go for partial fractions. That is a by e power j omega plus b by e power j omega, that like. and find the value of A and B and find h of t. That is inverse Fourier transform. Inverse Fourier transform is from here to here. Okay. Okay. Here to here means again we will get this one only. No problem. Okay. Next, 12th question. Same problem. Okay. Almost same question. Almost similar question. Here, difference equation. Second order difference equation is given. We have to find maybe frequency response. Let us see frequency response. So here apply Fourier transform. Y of n is y of omega minus 3/4. Here n minus 1. Here minus 1. So e power minus j omega. Okay. Next 1/8. N minus 2. E power minus 2 j omega. Okay. So 2 x of omega. Take y of omega common. Here x of omega. Y of omega by x of omega is h of omega. H of omega is the frequency response. Okay. Frequency response. Here we have to find h of n. That is impulse response. See here. Impulse response. These type of problems are very, very important. So this problem is very, very important. Previous problem is only frequency response, but here we have to find a impulse response. Okay. So factor these question. Okay. Factor this one. Factors are 1 minus 1/2 e power j omega, 1 minus 1/4 e power j omega. Now take a partial fractions. A by 1 minus 1/2 j omega plus b by 1 minus 1/4 j omega. Already this type of partial fractions already we done. Okay. This value is equal to 0. Now e power minus j omega value is 2. E power minus j omega value is 2 for A. For B, put this value is equal to 0. E power minus j omega is equal to 4. For B, e power minus j omega is equal to 4. Okay. For this one, take this main equation, that is h of omega. From this equation, to calculate A value, we have to hide this one. So multiply this one. So this term and this term will cancel. 2 by this one will be there. So 2 by 1 minus 1/4 into e power minus j omega is 2. So 2. Next, here also for B value, hide this value. So this value is multiply. This value will be cancelled. 2 by this value. So this value minus 2. So A value is 4. B value is minus 2. Okay. Substitute these values and now apply inverse Fourier transform. Okay. This is the formula. Okay. Whatever may be the value in place of A, that will come here. Okay. Whole power n. So here 1/2 whole power n. Here 1/4 whole power n. Okay. Completed. This is very, very important and very simple. Maybe I'm expecting this type of question will be in exam. Okay. From unit 4, this type of problem for 7 marks. Maybe I'm expecting. Okay. Next. 13th question. 13th question. This is the 13th. Okay. 13th question. This is also like that problem only. Okay. X of n is given. That means in previous problem, h of omega is given. No. For that one, input is when our input is this one, find the value. He told that when our input is this, okay, find the value. Okay. So for this one, already from this formula, okay, from this formula, here A value is 1/4. So what is this value? 1 by 1 minus 1/4. Okay, 1 by 1 minus 1/4 e power minus j omega. Okay, this is x of omega. H of omega. Okay, we know h of omega is y of omega by x of omega. So y of omega is x of omega into h of omega. So y of omega is equal to x of omega into h of omega into x of omega. Okay, multiply these two and apply partial fractions. Okay, so apply partial fractions. Now see here, this is in the form of square. Okay, square means 1 time, 2 times. Okay, square means 1 time and 2 times. If it is cube means 1 time, 2 times, 3 times. Okay, so 1 time, 2 times. This term is this one. Okay, A by this term, b by this term and c by this term. Already we know this is the term. Okay, for b value, take this total term including square. So including square, now e power j omega is 4. In this term, put b value so that this term get cancelled. And what is the term? 2 by 1 minus 1 by 2 e power minus j. Okay, 2 by 1 minus 1 by 2 e power j. That is minus 2. So b value is minus 2. Next, c value. C value, put this term to 0. That is e power minus j is 2. Okay, e power minus j is 2. Now this term and this term will be cancelled. 2 by this term. 2 by this term square. That is 8. Okay. For what about this term, a term? Already, if you put a e power minus j omega is equal to 4, b value will be obtained. So here not possible to find the b value. So we have to take this complete equation. Okay, this total equation. This is main equation and this partial equation. This total equation, and put e power minus j omega is equal to 0. Okay, so 2 by 1 minus 0, 1 minus 0. Okay, 2 by 1 minus 0, 1 minus 0. A by 1 minus 0, a by 1 minus 0. Already we know b value. What is the b value? Minus 2. Minus 2. 1 minus plus. Next, c value. What is c value? 8. Suppose 8 by 1 minus 0. So now 2 is equal to a minus 2 plus 8. A plus 6 is equal to 2. A is equal to minus. Now a is equal to minus 4. B is equal to minus 2 and c is equal to 8. Okay, again same formula. Already we know this formula. What is the formula? What is the formula? 1 by 1 minus 1 by 4 e power minus j omega is equal to 1 by 4 whole power n u of n. Okay, general formula is 1 minus a e power minus j omega is equal to a power n u of n. Okay, simple formula. Already this formula is previous problem formula. So what is the 1 by 4? You will get this value here. So here 1 by 4 minus 4 into 1 by 4 whole power n u of n. 2 minus 2 minus 2. Okay, minus 2. Here we have 1 by 4 whole power n, but here square is there. Okay, square is there. So here we have n plus 1. If it is cube is there, n plus 2. If it is power 4 is there, n plus 3. That is 2 minus 1. Here 1. Okay. So this is the rarest formula, no problem. So here it is 2 minus 1, 1, n plus 1. Okay. Next 1 by 4 whole power n plus here 1 by 2, 8 into 1 by 2 whole power n u of n. Okay. Take u of n common. This is the answer. This type of problems are very, very important. Only difficulty is this one. Okay. Only difficulty is this one. Here square is there. For square term n plus 1. For cube term n plus 2. Okay. From here we will complete. We have completed the 8. Now model 9. Are you listening?
Yes, sir.
Yes, sir.
Okay. How many members are there? Oh, 4 members are there. No problem. 3 hours, 14 minutes. Okay. Next, model number 9. Here, model number 9 is ROC. This model number is very, very important. This model number belongs to ROC. Here, ROC means region of convergence. Okay. Region of convergence. Here we have this belongs to unit 5. This belongs to unit 5, part 1 and part 2. Part 1 is Laplace transformation and part 2 is Z transformation. Okay. So it is very, very important for Laplace transformation. Always this type of problem is given for maximum Laplace transformation. Okay. In Z transformation, inverse Z transform is given. Okay. From Z transforms, inverse Z transform problems are given. Okay. Next. So region of convergence. We have two types of regional convergence. Here we have two types of region of convergence. One is normal region of convergence, and second one is advanced ROC. Okay. Normal is okay. Normally, generally, this type of problems are very, very important. Okay. If paper is very, very tough, then these advanced ROC will be given. So we are preparing for that one also. Okay. I hope in four sets, one set has a advanced ROC, because one set may be given tough. Okay. So in this tough, it will given, instead of normal ROC, he will given advanced ROC. Okay. Let us see. Next, see here ROC. Very, very important. You have to find the process. What is the process? Okay. If you know the process, very, very easy. ROC is very easy. Advanced ROC also easy. No problem. Okay. Advanced ROC also easy. Okay. If you know the procedure is very, very simple. I will tell the procedure. Okay. Now see here. Find the Laplace transformation of the signals x of t, u of minus t. Okay, u of minus t is given. You have to find Laplace transformation and also find their ROCs. See here. So many students don't see this question. Okay. Find the Laplace transformation. Okay. A is given, B is given, and start the answer. Okay. They don't look for the last line. That is very, very important point. Important question, not important point. Okay. So you have to read the question completely. Okay. This type of questions will be also given. First, find the Laplace transformation is given, and inputs are given. Okay. We have to find Laplace transformation and go for the answer. But here, see here, find their ROCs also. Okay. Region of convergence. Region of convergence means, already we have discussed in the class that region of convergence means it has a solution. Okay. It has solution in that region. Okay. So region of convergence. Now here given x of u of minus t. Already we know what is u of minus t. U of minus t is left side. Okay. U of t is right side. So u of minus t is left side. So it belongs to t less than 0. Okay. Right side means t greater than 0. It belongs to left side. So t less than 0. Okay. You have to write this value 0 when t greater than 0. Okay. Next is equal to 1 when t less than 0. This is very, very important. Okay. To confuse you, this type of critical questions will be given. Okay. You have to look for whether it is u of t or it is u of minus t. Here u of minus t is given. So for u of minus t is equal to 1 when t less than 0. Okay. So for x of t, Laplace transformation is x of s. Now for x of t, okay, for x of t, it is x of s. This is the general formula. Okay. This is the standard and general formula for Laplace transformation. Okay. We have already in Fourier transformation this type of formula. Okay. This type of formula is there in Fourier transform. What is that formula? Minus infinity to infinity, integral minus infinity to infinity x of t e power minus j omega t. Okay. So in place of s, when we put j omega minus j omega t, this formula is converted to Fourier transform. Okay. In place of j omega, if you put s, then it is converted to Laplace transformation. Okay. So one change, it will becomes to Fourier transform. One change, when we put j omega is equal to s, it is converted to Laplace transformation. This is the standard formula for Laplace transformation. Okay. So now we have to put a Laplace transformation. What is x of t? X of t is u of minus t. Put u of minus t. E power minus st dt. Okay. These limits are minus infinity infinity. But here less than 0 means limits are minus infinity to 0. Okay. So this is minus infinity to 0. Minus infinity to 0. Value is 1. Already we write value is 1. So value is 1. Now minus infinity infinity e power minus st by minus s minus infinity infinity. This is minus 1 by s e power 0 and e power minus infinity. Okay, e power minus infinity is already we know e power minus infinity is 0. Okay, so e power 0 is 1 minus 1 by s. Okay, so Laplace transformation of u of minus t is minus 1 by s. Laplace transformation of u of t is 1 by s. Already we know u of t is 1 by s. U of minus t is minus 1 by s. Okay. So here, now we have to find ROC, region of convergence. Okay. See here, always ROC is written in the standard notation only. Okay. This is the standard notation. ROC, semicolon. RE of S. RE of S means real part of S. Already we know S is equal to A plus JB. A plus JB. That means S has both real part and imaginary part. Okay. So in ROC, we take only real part only. Okay. So for real part, it is represented RE. Okay. RE. RE of S. That is real part of S. Okay. Real part of S. What is the value here? Greater than or less than? Less than. Why? It is U of minus t. For u of minus t it is less than 0. Okay, for u of minus t it is less than 0. So real part of s also less than 0. So region of convergence is less than 0. Okay, so this is the diagram. Okay, ROC of u of minus t. Okay, like x-axis and y-axis you have to write, but here sigma and j omega. Okay, because we have s is equal to sigma plus j omega. Instead of a plus jb, we take sigma plus j omega. This is real part and this is imaginary part. Okay. So here x-axis is sigma and y-axis j omega. So x-axis sigma and y-axis j omega. Here region of convergence is left hand side. So shade all the left hand side. Okay, and write ROC of in place of, see here, ROC of RE of S. RE of S means real part of S. What is the real part of S? Real part of S is sigma. So in place of real part of S, we can write sigma. Okay, don't confuse. Real part of S means sigma. So ROC, comma, real part of sigma, real part of S is sigma less than 0. Okay, we can write RE of S less than 0, or you can write sigma less than 0. Okay, you can write anything. That is your wish. Okay, so shading of less than 0 is the ROC. Okay, this is okay. This is the procedure. Okay, now you know the procedure. Now these type of problems will be given. B type. Okay, second problem is there. No, this type of problems will be given in the exam, maybe expected. Okay, so here we have to look for the, it is given u of t or u of minus t. Okay, first you have to check that in question whether it is given u of t or u of minus t. U of minus t means left hand side, u of t means right hand side. Okay, left hand side means minus infinity to 0. Okay, limits are, okay, integration minus infinity to 0. Okay, right side means integration 0 to infinity. Okay, so substitute x of t in this standard equation of Laplace transformation. Okay, standard equation of Laplace transformation is integration minus infinity to infinity x of t e power minus st dt. Okay, in place of x of t, substitute this value e power minus t u of t plus e power minus 4t u of t. Okay, now what is u of t? U of t is 1 for t greater than 0. U of t is 0 for t less than 0. Okay, you have to write this point also. Very, very important. Okay, next. Now this is the value, and this u of t is 1. This u of t also 1. Now what is the limits from 0 to infinity. Okay, minus infinity to infinity is converted into 0 to infinity, because u of t is t greater than 0. T greater than 0 means 0 to infinity. So this is 0 to infinity. Okay, these e power minus st, the e power minus st. Okay, now whenever it is 0 to infinity, take minus common. Okay, 0 to infinity, we have to take a minus common, minus. Okay, from these two, take t common. Okay, left side minus common, right side t common. What is the remaining term? 1 plus s. Okay, 1 plus s. So always in Laplace transformation, s should be written first, and there is no coefficient should be there for s. That is very, very important. In Laplace transformation, there should be no coefficient for s. If there is any coefficient, take that common. If it is as, take a common and minus a. That should be s plus 1 by a. Okay, this is very, very important point. So for Laplace transformation, we have to write s terms first. Okay, if you have any coefficients, take that coefficients common. Okay, make s coefficient is 1 only. So minus of s plus 1 into t, here also minus of s plus 4 into t. Okay, apply integration and substitute infinity. Okay, substitute limits. E power minus infinity is 0, e power 0 is 1. So minus of minus plus 1 by s plus 1 and 1 by s plus 2. Okay, here in this material, I write these explanation here, but in exam, you have to write this explanation in last integration. Okay, this is the last integration. So in between these two, you have to write this explanation. Okay, in material, I write the here, but these points, these 3 points, okay, these 3 points should be written in last integration. Okay, so what is this one? This is ROC. Okay, we have 2 terms, so that you have 2 types of ROCs. Okay, ROC1, ROC2. From these 2 ROCs, you have to find the common ROC, that is final ROC. Okay, that should be shaded in this ROC diagram. Okay, now see here. Now this is why we are writing at integrations only, because here 1 by s plus 1, we don't know whether it is 0 to infinity or minus infinity to infinity. Okay, so if it is 0 to infinity, it is greater than 0. If it is minus infinity to 0, it is less than 0. Okay, so ROS will be changed. So here these two are 0 to infinity, 0 to infinity. So here we can write these value, substitute this value to 0. S is equal to minus 1, S is equal to minus 4. So how we have to write? S plus 1 greater than 0. Why greater than 0? 0 to infinity. So greater than 0. Here also S plus 4 greater than 0. Why greater than 0? 0 to infinity. So S plus 4 greater than 0. Okay. Now S greater than minus 1. S greater than minus 4. Okay. S greater than minus 1. S greater than minus 4. Okay. So this sentence should be write clearly. Okay, in exam this sentence should be write clearly. Convergence, like this only you have to write convergence if RE of S. What is RE of S? Real part of S. So this is called sigma also. So RE of S greater than minus 1. For this one, greater than minus 1. This one, convergence if RE of S greater than minus 4, greater than minus 4. Because s plus 1 is equal to 0, s minus 1 is okay. This point you can write or neglect, but this point should be write clearly. Okay, like this only you have to write. Next, put the bracket for these two, common of these two. Okay, common of these two, overall convergence. Okay, how we have to calculate overall convergence? From the graph. Okay, from the graph you have to calculate overall convergence. Okay, don't write before. First of all, with the graph, you have to find what is the common portion from these two, and you have to write the answer. Okay, now see here. S is equal to minus 1. S is equal to minus 1. This is S plane. Okay, this is S plane. X axis has sigma, y axis has j omega, real part and imaginary part. This is S plane. Okay, this like you have to write. Next, this is 0. Next, S is equal to minus 1. So minus 1. Write one straight line. Okay, one straight line. S is equal to minus 1. This is greater than 0. Okay, it is greater than minus 1. So greater than minus 1. Greater than minus 1 means right side. Greater than means right side. less than means left side. Okay, remember that point. Greater than means right side, less than means left side. So it is greater than -1. Greater than -1, right side. You have to shade the right side portion. Next, s is equal to -4. S is equal to -4. Write a straight line. Okay, it is greater than -4. Again, another straight lines. Okay, diagonal. I take diagonal. We can take anyone, no problem. Okay, and completely shade this point. Now, out of these two, what is the shaded part? Shaded part always this shaded part comes after -1. So comes after -1 means after -1 means greater than, less than -1 means less than. If it is in between means -4 less than t less than -1, -4 less than s less than -1. That like, okay. If it is completely right side of -1, so RE of s greater than -1. Okay. Now take the LCM of these two and write the value. Okay. Now semicolon ROC. Okay. This is the standard notation. ROC, RE of s greater than -1. Okay. These type of problems are very, very important. Okay. In unit 4, this is unit 5, part 1, that is Laplace transformation. ROC is the first important question. Okay. Whether it is normal or advanced ROC. Okay. Next, this one, this is advanced. This problem belongs to advanced ROC. Okay. Okay. In advanced ROC, they will ask stability, casual, absolute integral. Okay. And they will give they will give ROCs. Okay. Before finding only, they will give ROCs. ROC greater than -4, ROC less than -4, ROC between -2 and -4. Okay. What is your justification? Is it correct for this equation? That like they ask. Okay. Otherwise, they will ask that what are the possibilities? Okay. What are the possibilities? You have to write all possibilities. Maximum possibilities are 3 possibilities. Okay. For one transfer function, we have maximum possibilities, 3 possibilities. Okay. Suppose we have a -2. Suppose we have -2, -4. Okay. Less than yes, less than -4. So you have less than -2 one possibility, greater than -4 one possibility, and between between -2 and -4 one possibility. So first possibility, second possibility, and third possibility. Suppose so we have 3 possibilities. Okay, like that you have to divide. Okay. Now see here what are the types? This type of advanced means, for advanced ROC, they will ask first one is stability and casual. Okay. Second one is they only give RE of s greater than -2, RE of s less than -4, and RE of s less than -4 less than -2. That like they only give. Okay, you have to find. Or third one is find all possibilities. Okay, like this you have to find. Okay, this is belongs to this one. Okay, we have only find this possibilities. Okay, 3 possibilities, maximum 3 possibilities. Okay. Okay, now we're going to this problem. Now h of s is given. H of s means, what is h of s? It is the h of w means transfer function or frequency response in a Fourier transform. Okay, in Fourier transform, h of w is frequency response or transfer function. Here h of s is transfer function. Okay, h of s is transfer function in Laplace transformation. Okay, s belongs to Laplace transformation, j omega belongs to Fourier transform. Okay. Now this is the standard question. Oppenheim is the standard textbook, and this is the standard question. Maybe this question directly come to exam or interchanging the values. Okay, on interchanging the values, this question will be come. Okay, but in this advanced second type and third type are very, very important. Okay, second model and third model, that is second type and third type are very, very important. Okay, these are also important, but that are the most important. Okay, now see here, s minus 1 by s plus 1, s minus 2. Okay, which is a proper fraction. In partial fractions, already we are covering in each and every problem about partial fractions. Okay, so model 10 will be minimized. Okay, minimized, only we will forward speedily completed model 10. Model 10 is only on partial fractions only. Okay, so proper function, what is proper function? Numerator should be less than denominator. Numerator should be less and denominator should be more. That is, here what is the order? S power 1, order is 1. Here order is s into s, s square, so order is 2. Numerator order is 1, denominator order is 2. So numerator is less than denominator, or else denominator should be always, denominator order should be greater than. So denominator is greater. Okay, if denominator is greater, then it is called proper function. If denominator and numerator are equal, and if denominator and numerator are equal, or numerator is greater, that is called improper fraction. Okay, whenever improper fraction is there, we have to make it to proper fraction and do the partial fractions. Okay, before partial fractions, we have to check whether it is proper function or not. Okay, proper function means denominator and numerator. Okay, denominator order is 1 and numerator order is 1 and denominator order is 2. So it is proper function. Okay, numerator is always less than denominator, or denominator is always greater than numerator. Okay, this is proper function. If it is improper function, okay, here order of numerator is 2 and order of denominator are also 2, or order of numerator is 3 and order of denominator is 2. Okay, so numerator is greater than denominator. Okay, so we have to make this improper fraction to proper fraction and apply partial fractions. Okay, this is the procedure. Almost partial fractions method are discussing here only. At that we can speedily we can calculate. Okay, okay, now proper fraction means numerator is less, denominator is more. Okay, then only you have to apply partial fractions. Otherwise you can't apply partial fractions. We have to make this improper fraction to proper fraction, and then only you have to apply partial fractions. Okay, so here given transfer function is proper fraction only. Okay, so a by s plus 1, b by s plus 2. So this is s plus 1 into h of s. So this s plus 1 get cancelled. S minus 1 by s minus 2, s minus 1 by s minus 2. Okay, in this manner only you have to write in exam. Okay, so don't directly substitute like this. Okay, you have to write what are the terms remaining and what are the value you are applying, and then only substitute. Okay, write this formula, what is the value going to substitute, what are the terms remaining, and what is the value going to substitute, and substitute answer. Okay, this is the partial fraction procedure. So s minus 1 by s minus 2. Okay, minus 1 by minus 1, minus 1 by minus 2, that is 2 by 3. So a value is 2 by 3. Next, for b value, b is equal to s minus 2. So s minus 2 into h of s. At s is equal to 2. So what are the remaining terms? S minus 2 get cancelled. S minus 1, s plus 1. S minus 1, s plus 1. S is equal to 2. 2 minus 1, 2 plus 1 is equal to 1 by 3. Okay, so a is equal to 2 by 3, b is equal to 1 by 3. Okay, this is the value. Now apply inverse Laplace transformation. Okay, apply inverse Laplace transformation. Laplace transformation of is there. See here also almost same formula. Okay, e power minus u of t in Fourier transform. In Fourier transform, same formula, e power minus t u of t is 1 by j omega plus, here in place of a is equal to 1 at. Okay, there minus at, here a is equal to 1, so 1 by j omega plus 1. Here also similar kind of formula is used in the unit 5 also. Once I will check in unit 5, most important question, most important formula is this one only. Most important, yes, this one, same. Only 3 formulas are there. Okay, only 3 formulas in Laplace transformation, and almost 3 formulas in Z transform. Only 6 formulas. Okay, these 6 formulas, 3 plus 3, these 6 formulas in unit 5 regularly used in every formula, that is every question. Okay, so what is the formula? Laplace transformation of e power minus at u of t. Okay, Laplace transformation. Laplace transformation is 1 by s plus a. Okay, in Fourier transform, e power minus at u of t. Okay, that is Fourier transform, same. Okay, 1 by, in place of s we put only j omega. That's the important point. Okay, same formula, but this same formula will be used in 2 units. See here, e power minus at u of t, Laplace transformation is 1 by s plus a. E power minus at u of t, Fourier transform is 1 by j omega plus a. In place of s, if you substitute in place of s j omega, it is transferred to Fourier transform. In place of j omega, if you substitute s, it is transferred to Laplace transformation. Okay, same formula. This 90% of the problems has this formula only in Fourier transform. This formula only in Fourier transform. Forward is Fourier transform, reverse is inverse Fourier transform. Okay. Now see here, applying inverse Fourier inverse Laplace transformation. Inverse Laplace transformation 2 by 3, 2 by 3. Here s plus 1. Okay, plus 1 means minus 1. Minus t u of t. 1 by 3, 1 by 3. S minus 2. Minus 2 means plus 2. Okay, plus 2 u of t. This is called impulse response. Okay, this is called frequency response. Okay, even though it is h of s also, it is called frequency response. H of omega is frequency response. H of s also frequency response. Okay, now frequency response, these frequency response are also called a transfer function. Okay, so in Laplace transformation, h of s is called transform. Okay, in Laplace transformation, h of s is called a transfer function. Okay, h of omega is called a transfer function or frequency response. Frequency response. This is in Fourier transform. Okay. One second.
Okay, sir.
Okay. Whereas in Laplace transformation, that is h of s. In Laplace transformation, this is called only transfer function. Okay. In Laplace transformation, this is called only transfer function. Whereas h of omega in frequency, that is Fourier transform, you can call it as a transfer function or frequency response. Okay. So here we have h of s. This h of s is called transfer function. Okay, so transfer function is obtained, and after transfer function, this is called a impulse response. Okay, almost these formulas in each and every chapter, that is chapter 4 and chapter 5. Okay, frequency response, here transfer function, there impulse response, here also impulse response. Okay, now this one h of t, impulse response is obtained. Okay, Impulse response is obtained. Now after this impulse response, why this one is calculating? Why this one is calculating? What is the remaining question he asked? Stability. Okay, he asked about stability, casual, absolute integral. Okay, for stability and casual, we have to calculate zeros and poles. Already we know if numerator is equal to 0, the values are called zeros. If denominator is equal to 0, these obtained values are called zeros. Okay, that only here mentioned here. So s minus 1 is equal to 0. So s is equal to 1 is called zeros. For poles, denominator part should be 0. So s plus 1 is equal to 0, s minus 2 is equal to 0. S plus 1 is equal to 0, s is equal to minus 1, s minus 2 is equal to 0, s is equal to 2. Okay, so we have 1 zeros and 2 poles. Okay, if numerator terms are equating to 0, then zeros obtained. If denominator terms are equating to 0, then poles are obtained. Okay, that point I write here. Okay, no problem. Now about stability. Okay, this is also same question, 15th question only. Okay, now we discuss about this formula. This is very, very difficult question. Okay, up to previous one, see here, up to here, problem is completed. Up to here, problem is completed. Okay, up to here, problem is completed. But here asked about stability, casual, absolute integral. This is very, very difficult problem. Okay, these two types are very easy. Second and third is very easy. For first one is very, very difficult. Okay, because to obtain stability and casual. Okay, let us see. It is difficult because we have to look for 2 to 3 times. Okay, this problem we have to look for 2 to 3 times. Okay, so 0. What is the zeros? 0 is at 1. Poles are at minus 1 comma 2. So zeros are denoted with small circles. Okay, now poles are denoted with into marks, x marks. So here x mark is there. This is a pole. Here x mark is there. This is pole. So pole is at 2 comma 2 comma minus 1. So 2 comma minus 1. Okay, now stability. Okay, see here this point, for stable system, the poles on right side of the graph are considered and pole should be contain j omega axis. Okay, so this is the j omega axis. Okay, if it contains j omega axis, here 2, that is, this is the line. This line cannot contain these j omega axis. Okay, so this is unstable. Okay, and here minus 1 also don't consider j omega, so it is unstable. Okay, see here minus 1 to 2. Okay, that indicates this is greater than 2. Okay, that is this area. Okay, this is less than minus 1, that is this area. Okay, so this area don't have this j omega axis, so it is unstable. This area also don't have a j omega axis, so this is unstable. Now it is minus 1 to 2, so this is the area. In this area we have j omega axis, so this is stable. Okay, let us see what they will discuss. So for stable system, the poles on right side of the graph are considered and poles should be contain j omega axis. Okay, this is the normal point. Okay, if right side pole 2 is considered j omega axis, so system is unstable. That is we discussed. Okay, when 2 is considered, right side portion is shaded and there is no j omega axis, so it is unstable. Okay, next point. If poles on right side and left side, okay, the poles on right side and left side are considered, then the system is stable. Okay, so figure B has that condition. What is the condition? Figure B has minus 1 and 2. That is, this is the area. In this area, we have j omega axis. So this has j omega axis. This system has stable. Okay. So absolutely, which is absolutely integrable. That means if it is stable, okay, then it is absolutely integrable. Okay. Now see, for C, ROC is shown that anti-casual and unstable for C. Okay, this is the C. Okay, that is left side of this portion. Left side of this portion, so unstable and also anti-casual. Okay, here see here, anti-casual means left side of the value. Okay, anti-casual means left side of this value, and for stable we have to consider this area. This area doesn't contain j omega axis. If j omega axis doesn't contain, it is unstable. Okay, but for casual and anti-casual, we have to consider left side. Okay, left side and two right side. Okay, that means it has both -1 and 2. Both sides means you have to consider, but here we have only one side, that is -1. -1 left side, so it is anti-casual. Anti-casual. Or else already we know that one concept, when waveform is left side the graph, then it is called anti-casual. When waveform is right side the graph, it is called casual. When the waveform left side and right side, then it is called non-casual. Already we know this concept. Okay, right side it is called casual. Right side it is called casual. If it is left side, it is anti-casual. If it is contain both sides, if it contains both sides, it is non-casual. Already we have in signals, we have this concept. In systems, it is in the concept called signals. Okay, but in the concept of systems, we have only two terms, casual and non-casual. Okay, so here we have casual, non-casual. Now we can say that this is right side. Okay, this is right side, so it is casual. Here we have left side, so it is anti-casual. Here we have both sides. Okay, here we have left side and right side, both sides. Both sides means is called non-casual. Okay, now see here what they written here. Figure C, ROC is anti-casual. Okay, so left side means anti-casual, and for stability, this should be considered. There is no chance to touch this j omega, so this will be unstable. Okay, so unstable. Okay, got this point? Now see here. Now see here. Already we obtained this value. Okay, already we obtained this value. Okay, absolutely integral. So 2/3 e power minus u of t. Here we have to find -1/3 e power 2t u of minus t. That is here before the equation is +1/3 u of t. Okay, so whenever 2 is there, we have to consider this one in left side. Okay, so this is -1/3, +1/3 becomes -1/3, u of t becomes minus u of t, u of minus t. Okay, now here both are not here anti-casual. Anti-casual means we have only here both. Anti-casual means both sides. Okay, sorry. Anti-casual means left side. So this portion also becomes a minus, and u of t becomes u of minus t. So -2/3 u of minus t, in place of u of t, u of minus t. So Here also u of minus t, u of minus t common, this one. Okay, that's why this problem is so much of difficult. Okay. Next, 17th problem. These type of problems are given in the question. Okay, this given means it is somewhat difficult. Okay, next type is given also somewhat difficult, but this type of question is given means it is very, very difficult. Okay, so now see here. Now see here, find the inverse Laplace if the regions of convergence, already they given the 4 types of region of convergence. Okay, now we have to say about the ROC. Okay, now we have to say about the ROC. RE of SN means RE of S means already we know it is region of convergence. Region of convergence, that is real part of S. Okay, ROC real part of S. So this problem is on ROC. This is X of S. X of S means transfer function is given. Okay, so this is a proper fraction. Okay, this is a proper fraction. Numerator is less than, denominator is greater than. So proper fraction taking partial fractions. Okay, every time you have to write this point. Okay, this is a proper fraction taking partial fraction. So a by s plus 4 plus b by s minus 2. Already we know how to find a value and b value. Okay, a value is minus 1 by 6 and b value is 1 by 6. Okay, so this is the value. Now apply inverse Laplace transformation, minus 1 by 6 into, already we know this formula. What is the formula? E power 2t u of t is 1 by s plus 1 by s minus 2. Here plus 2 means minus 2. Minus 2 means plus 2. Okay, reverse. So here plus 4 means minus 4. E power minus 4t u of t. Next here minus 2, that is plus 2. E power 2t u of t. Okay, already we know single formula. Okay, always the single formula is coming. We have only 2 formulas. For continuous, this formula, and for discontinuous, discrete, another formula. Only these 2 formulas are continuing. Okay. Next, now consider the given ROCs. Okay, from this we have to consider this this given ROCs. Now see here, minus 1 by 6 plus 1 by 6. Here we have u of t. Here also we have u of t. Now the concept is, which direction you have minus 4 and 2. What are the poles here? Okay, what are the poles here? S is equal to minus 4, S is equal to 2. So S is equal to minus 4, S is equal to 2 poles. Okay, so if minus 4 is not stable, this term will become minus, here minus will come, that is plus 1 by 6. U of t becomes u of minus t. That is the concept. Okay, if s is equal to 2 is unstable, then this becomes minus 1 by 6. U of t becomes u of minus t. If 2 are unstable, then plus 1 by 6 u of minus t minus 1 by 6 u of minus t. That is the concept. Okay, this concept is taken from the previous problem. Okay, this is the simplified version. Okay, now see here. Now see here, already given 4 conditions. Okay, now we taken 3 possibilities. Okay, now we have taken 3 possibilities. Okay, first possibility is, what are the poles here? Minus 4 and 2. Okay, what is the first possibility? Minus 4 less than minus 4. This is the first possibility. Second possibility is greater than 2. Second possibility. And the third possibility is in between minus 4 and 2. Okay, this is the general formula. Okay, this is the general formula. This like only they given problems also. Okay, so these problem also given like this only. So see here, what is the first question? ROC of minus 4 to 2. Okay, so for this one we have to draw a graph. This is the graph. Okay, minus 4 to 2. Okay, ROC is minus 4 to 2. This region contains j omega axis, so it is stable. Okay, that is the concept. So minus 4, see here, minus 4 lies on the left side of ROC. Okay, left side of ROC is casual. Next, lies on the, this is, see here, this is very, very important point. Left side means casual. Okay, here this is the concept. Okay, here this is the concept. If minus 4 is left side, this is casual. always right side is wrong side. Okay, here we have to consider right side is wrong side, left side is right side. Okay, right side. Okay, RIGHT, right side. So -4 is left side, so it is casual. 2 is on right side, hence it is anti-casual. Okay, got the pointer? If it is casual, okay, equation is as it is. Okay, previously we got one equation, no, -1/6, that value. Hello.
Yes,
Ah,
sir.
Sir.
చెప్పండి ఒకసారి. చెప్పండి ఒకసారి. ఓకే, 1 second.
Okay, sir.
ఓకే. 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 కాల్ అవుట్ వచ్చింది. నో ప్రాబ్లమ్. Okay, but already now he already given first question -4 and 4. It already given -4 and 4. This is the question given. So related to this question, this is the graph. Okay, for this graph, -4 is in left side, so it is casual. 2 is on right side, so it is anti-casual. So this is for a casual, that is for casual. For casual, what is the value? -4. Here, which term has -4? This term has -4. So this has no change. Okay, for casual, there is no change in the term. Okay, previously we got one equation. In this equation, two terms are there. Okay, these second term cannot be changed because it is casual. Okay, that is h of t is normal. Okay, now 2 is on right side, so it is anti-casual. So h of t has minus symbol and u of minus t. So minus is here, -1 by t. Okay, anti-casual means what is the value? 2. This is 2. Okay, so this is the term. For this term we have minus. Okay, previously it is no minus, so here -1 by 6 e power minus 2t. This u of t is changed to u of minus t. Okay, ఈ పాయింట్ అర్థమైందా? ఏమై ఈ పాయింట్ అర్థమైందా? ఓకే, సో pole is -4. -4 means this is the term. Okay, -4, so this is the term. For -4 it is casual. Okay, అర్థమైందా?
సార్
ఓకే, అర్థమైందా ఈ పాయింట్ ఎలా వచ్చిందో?
ఎస్ సార్, అర్థమైంది సార్.
ఓకే, సేమ్ ఇదే కాన్సెప్ట్, ముందు ప్రాబ్లం కూడా ఇదే కాన్సెప్ట్, కాబట్టి డీప్కి వెళ్ళిపోయాడు అంతే ముందు ప్రాబ్లంలో. ఓకే, ఈ ప్రాబ్లం జస్ట్ పైపైన చెప్పేస్తున్నాం. ఎలాగా? ఇఫ్ ఇట్ ఈస్ -4, హియర్ -4 ఈజ్ ఇన్ లెఫ్ట్ సైడ్, సో ఇట్ ఈస్ casual. 2 is on right side, so it is anti-casual. If it is casual, no change in the term. No change in the term. ఈ term ఎలా వచ్చింది? Previously we got this term. Okay, this x of t we have previously. So in this equation, second term is no change. Next, x of 2, that is a pole is 2. Pole is 2 means this is the term. In this term, that is anti-casual. Anti-casual means the term should be changed so that minus and u of minus t. Okay, so minus, ఇక్కడ ముందు మైనస్ లేదు, సపోజ్. సో హియర్ వీ హ్యావ్ టు పుట్ -1 by 6 e power 2t u of t. Here in place of u of t, you have to replace with u of minus t. Okay, this is the only change. Next second question is RE of greater than 2. Okay, greater than 2 means which diagram? A, B, C, B diagram. Okay, greater than 2. Greater than 2, this is the shaded part. So this is the diagram. In this diagram, 2 is on right side. 2 is on right side means anti-casual. Left side means casual. So 2 is anti-casual. So greater than 2. Greater than 2. So greater than 2. ఇక్కడ ఏంటంటే here he taken the value 2. Okay, here value is taken 2. So greater than 2. Greater than 2 means this is the area. This is the one second. Okay, this is the area. In this area, 2 poles on left side. Okay, -4 is on left side and 2 is on left side. Okay, so these two are a casual. ఈ పాయింట్ అర్థమైందా? ఎప్పుడు కూడా మనకి లెఫ్ట్ సైడే ఉండాలి. లెఫ్ట్ సైడ్ ఉంటే క్యాజువల్, రైట్ సైడ్ ఉంటే యాంటీ క్యాజువల్. ఓకే, ఈ ఏరియాకి హియర్ వీ హ్యావ్ లెఫ్ట్ సైడ్, సో క్యాజువల్. హియర్ వీ హ్యావ్ రైట్ సైడ్, సో యాంటీ క్యాజువల్. Here we have both -4 and 2 is in left side. Okay, both -4 and 2 is in left side. So these two are casual. Okay, అదే పాయింట్ ఇక్కడ చెప్పాడు. -4 and 2 lies on the left side of ROC, so casual. Casual means no change. Okay, previous గా ఏదైతే ఈక్వేషన్ ఉంటుందో సేమ్ ఈక్వేషన్, no change. Next, less than -4. Okay, Now less than -4. Less than -4 means this one, less than -4. ఓకే, ఈ ఏరియాకి పోల్స్ రెండు కూడా రైట్ సైడ్ ఉన్నాయా లెఫ్ట్ సైడ్ ఉన్నాయా? -4 and 2 ఆర్ రైట్ సైడ్ ఉన్నాయి కదా. ఈ ఏరియాకి ROC ఏరియాకి రైట్ సైడ్ ఉన్నాయి కదా, -4 -2 -4 2.
అవును సార్.
ఓకే, ఎప్పుడు కూడా ఎలా ఉండాలి మనకి? ఏరియాకి లెఫ్ట్ సైడ్ ఉండాలి. ఎప్పుడు కూడా మనకి లెఫ్ట్ సైడ్ ఉంటేనే క్యాజువల్ అండ్ సేఫ్, రైట్ సైడ్ ఉంటే యాంటీ క్యాజువల్. ఓకే, సో -4 and 2 lies on the right side. So -4 and 2 both are anti casual. ఓకే, ఇక్కడ అదే చెప్పేది చూద్దాం. లైస్ ఆన్ రైట్ సైడ్ ఆఫ్ ROC, సో యాంటీ క్యాజువల్, అంతే కదా. రైట్ సైడ్ ఉంటే యాంటీ క్యాజువల్. చేంజెస్
Anti-casual.
బోత్ టర్మ్స్. ఇప్పుడు ఏం చేస్తాం, రెండు టర్మ్స్ కి చేంజ్ చేసేస్తాం. అంటే ఇది స్టాండర్డ్ ఈక్వేషన్. ఈ స్టాండర్డ్ ఈక్వేషన్ ఈ టర్మ్ చేంజ్ అవుతుంది, ఈ టర్మ్ చేంజ్ అవుతుంది. ఇక్కడ మైనస్ పెట్టండి, -1/6 u of t ప్లేస్ లో u of -t. ఇక్కడ మైనస్ పెట్టండి, -of ప్లస్ 1/6 u of -4 u of t ప్లేస్ లో u of -t రావాలి ఇక్కడ. ఓకే,
ఓకే
ఇక్కడ -t రావాలి, ఇక్కడ -t పెట్టలేదు, -t వస్తుంది. ఓకే, నెక్స్ట్ ఫోర్త్ కండిషన్ ఏమి ఇచ్చాడు? 2 less than -4. ఓకే, అంటే ఫస్ట్ లెఫ్ట్ సైడ్ ఏం రావాలి? 2 రావాలి, రైట్ సైడ్ -4 రావాలి. మనకి ఎప్పుడు కూడా లెఫ్ట్ సైడ్ ఏ వాల్యూస్ ఉంటాయి? నెగిటివ్ వాల్యూస్ కదా ఉంటాయి. లెఫ్ట్ సైడ్ ఆల్వేస్ వీ హ్యావ్ negative values, right side we have positive values.
పాజిటివ్.
Okay, but here given that left side positive value, right side negative value, that is not possible. So directly we write not possible. It is not possible. ROC doesn't exist. Okay, ఇలాంటి ప్రాబ్లమ్స్ ఇచ్చినప్పుడు it is very difficult. అంటే ఫస్ట్ దాంతో కంపేర్ చేస్తే it is somewhat okay. Okay, the main point is always the pole should be lies on the left side of the area. Okay, area ki left side unte casual, so no change in the terms. If poles is on right side, then poles will be changed. Okay, so it is anti casual and terms are changed. What is the changing term? Minus sign should be there, and in place of u of t, u of -t should be placed. Okay, ఈ పాయింట్ అర్థమైందా? ఓకే, ఇప్పుడు ఏంటంటే వాడు క్వశ్చన్ లో ఇవి ఇచ్చాడు కదా, ఇది ఇవ్వకుండా యూ హ్యావ్ టు ఫైండ్ ఆల్ ది పాసిబిలిటీస్. ఓకే, యూ హ్యావ్ టు ఫైండ్ ఆల్ ది పాసిబిలిటీస్ ఎప్పుడు ఎలా ఉంటాయి? కండిషన్స్ 3 కండిషన్స్ లో ఉంటాయి. ఓకే, ఫస్ట్ కండిషన్ ఇస్ లెస్ దాన్, సెకండ్ కండిషన్ ఇస్ గ్రేటర్ దాన్, థర్డ్ కండిషన్ ఇస్ ఇన్ బిట్వీన్. ఇదే కండిషన్స్ ఉంటాయి. ఓకే, ఇది గుర్తుపెట్టుకుంటే చాలు. ఓకే, నెక్స్ట్ ప్రాబ్లం చేద్దాం. This is the next problem. What is the problem here? Problem రాయలేదా? 17 problem. ఓకే, ఈ ప్రాబ్లం రాయలేదు అనుకుంటా.
17 వచ్చింది సార్.
17 వచ్చిందా?
వచ్చింది. ఇంకా పేజ్ వెనక్కి.
ఇది 17th.
ఇది 17.
ఓకే 17th. ఓకే, 15th చూడండి. ఇప్పుడు మనం చెప్పుకుంది 17th. 15th ప్రాబ్లం.
ఇది 15 సార్.
15th. ఓకే, సరే, నేను ప్రాబ్లం చెప్తాను.
ఓకే సార్.
ప్రాబ్లం చెప్తాను, ఒకసారి ఉండండి, ఒకటి యాడ్ చేస్తాను.
ఓకే.
యాడ్ చేద్దాం. ఆ, 10:30 అయిపోయిందా? ఇంకా
స్టార్ట్ చేయండి.
లేట్ అవడం స్టార్ట్ అయింది. 7 o'clock ఎగ్జాక్ట్ గా స్టార్ట్ అయ్యాం. ఓకే, ఓకే, ఫైండ్ ది ఆల్ పాసిబిలిటీస్ అని చెప్పారు కదా. నౌ ఐఎమ్ కన్సిడరింగ్ దట్ ప్రాబ్లం విత్ ఆల్ పాసిబిలిటీస్. ఓకే, దిస్ ఈస్ ది మోస్ట్ ఇంపార్టెంట్. దిస్ ఈస్ అడ్వాన్స్డ్, ROC అడ్వాన్స్డ్, and this is the most difficult. అంటే examiner point of view లో this is the most difficult question. Okay, but మన point of view లో ముందు చెప్పుకున్నది most difficult question. Advanced all possibilities question, all possibilities కదా. Okay, here is the question. 19th question. Okay, in material it is example 19. Okay, example 19, that is Laplace transformation unit 5. Okay, now here given question is find all the possibilities. Find all possibilities of impulse function, impulse responses of ATA system ఏదో చెప్పాడు. ఓకే, డిఫరెన్షియల్ ఈక్వేషన్ ఇచ్చాడు టీ స్క్వేర్ వై ఆఫ్ టీ. ఇంతకు ముందు అయితే ట్రాన్స్ఫర్ ఫంక్షన్ ఇచ్చేవాడు, అంటే హెచ్ ఆఫ్ ఎస్ ఈస్ గివెన్, బట్ హియర్ ట్రాన్స్ఫర్ ఫంక్షన్ ఇస్ నాట్ గివెన్, వీ హావ్ టు ఫైండ్ ద ట్రాన్స్ఫర్ ఫంక్షన్. ఇలాంటి ప్రాబ్లమ్స్ కొంచెం డిఫికల్ట్, అంటే డిఫికల్ట్ కింద అనుకుంటారు. ఇలాంటి ప్రాబ్లమ్స్ మనకి ఎగ్జామ్ లో ఇస్తారన్నమాట. ఓకే, హియర్ వీ హావ్ టు ఫైండ్ Laplace transformation, that is this is called transfer function. Okay, we have to find transfer function also. Minus 3 y of t is equal to x of t. This is the given question. Okay, now apply Laplace transformation on both sides. Okay, already we have one formula, Laplace transformation of d square y of t by dt square. Okay, if it is d square, Laplace transformation s square into y of s. Okay, if it is d cube, s cube into y of s. Okay, so it is d square, so s square into y of s minus 2 into s into y of s minus 3 into y of s is equal to x of s. Okay, y of s common తీయండి, y of s కామన్ తీస్తే s స్క్వేర్ మైనస్ 2s మైనస్ 3 ఈజ్ ఈక్వల్ టు x ఆఫ్ s. ఓకే, ట్రాన్స్ఫర్ ఫంక్షన్ ఫార్ములా ఏంటి? ట్రాన్స్ఫర్ ఫంక్షన్ ఫార్ములా y ఆఫ్ s బై x ఆఫ్ s. ఓకే, సో y ఆఫ్ s బై x ఆఫ్ s, y ఆఫ్ s బై x ఆఫ్ s. దీన్నే మనం ఏమంటున్నాం? h ఆఫ్ s. h ఆఫ్ s ఈక్వల్ టు, ఓకే, ఇది ఎంత అవుతుంది? 1 బై s స్క్వేర్ మైనస్ 2s మైనస్ 3. ఓకే, ఇది ఫ్యాక్టర్స్ కింద డివైడ్ చేస్తే ఏమొస్తుంది? s మైనస్ 3 s ప్లస్ 1. ఓకే, దీస్ ద ఫ్యాక్టర్స్. లాప్లాస్ అదే పార్షియల్ ఫ్రాక్షన్స్. ఇది ప్రాపర్ ఫ్రాక్షనా, ఇంప్రాపర్ ఫ్రాక్షనా? ప్రాపర్ ఫ్రాక్షన్. ఎలా చెప్తున్నారు? న్యూమరేటర్ ఆర్డర్ ఈజ్ లెస్ దాన్ డినామినేటర్ ఆర్డర్. ఓకే, s మైనస్ 3 ప్లస్ b బై s ప్లస్ 1. ఓకే, ఇంకా టైం వేస్ట్ చేయకుండా ఈ ఆన్సర్ రాసేస్తున్నాం. ఓకే, ఏ వాల్యూ ఈజ్ 1/2 s మైనస్ 3. ఓకే, ఇది ఎలా ఫైండ్ చేయాలి మీకు తెలుసు కదా, 1/2 ఇంటూ s ప్లస్ 1. ఓకే, నౌ హెచ్ ఆఫ్ ఎస్ తెలిసింది. ఇందులో ఇక్కడ పోల్స్ ఎన్ని? పోల్స్ ఈజ్ ఈక్వల్ టు s ఈజ్ ఈక్వల్ టు 3, -1. ఓకే, 2 పోల్స్. ఎన్ని పోల్స్ ఇక్కడ? 2 పోల్స్, 3, -1. జీరోస్ ఏమైనా ఉన్నాయా? జీరోస్ ఏం లేవు, ఎందుకంటే న్యూమరేటర్ ఈజ్ 1. ఓకే, సో హియర్ వీ హ్యావ్ 2 టైమ్స్ 1/2 into s minus 3 This is term 1 minus 1 by 2 into s plus 1. This is term 2. ఓకే, ఇప్పుడు ఎన్ని పాసిబిలిటీస్ ఉంటాయి? ఇక్కడ ఆల్రెడీ గ్రాఫ్ గీస్తాను చూడండి. ఓకే, పాసిబిలిటీస్ చేసుకోవడానికి గ్రాఫ్ గీస్తాం. ఓకే, గ్రాఫ్ ఏంటి? సిగ్మా జే ఒమేగా. ఓకే, సిగ్మా జే ఒమేగా, దీన్ని ఏమంటాం? ఎస్ ప్లేన్ అంటాం. ఓకే, పోల్స్ ఏంటి? 3, -1. ఓకే, 3, -1. ఓకే, -1 కి ఒక లైన్ గీయండి. నెక్స్ట్ 3 కి ఒక లైన్ గీయండి. ఇప్పుడు పాసిబిలిటీస్ ఏమో చెప్పండి. వాట్ ఆర్ ద పాసిబిలిటీస్? Three possibilities. Okay, less than -1, greater than 3, and in between -1 and 3. Okay, 3 possibilities. This is called RE of S, RE of S less than -1. This is called RE of S greater than 3. This is -1 less than RE of S less than 3. Okay, 3 possibilities. ఎప్పుడైనా సరే ఇలాగే ఉంటాయి. 3 పాసిబిలిటీస్ ఉంటాయి మాక్సిమం. ఓకే, అంటే 2 పోల్స్ వచ్చినాయి అంటే 3 పాసిబిలిటీస్. మాక్సిమం 2 పోల్స్ వచ్చేలాగా చేస్తారు. ఓకే, సో నౌ వాట్ ఆర్ ద పాసిబిలిటీస్? Possibilities are, first possibility is ROC RE of S greater than 3. Next, ROC of C RE of S less than -1. Next, ROC of C, okay, -1 less than RE of S less than 3. Okay, these are the 3 possibilities. Okay, అయితే ఫస్ట్ పాసిబిలిటీ లేదంటే ఇక్కడే మీరు ఏం చేస్తారంటే దీనికి ఇది h of s కదా, we have to find h of t. Okay, h of t means impulse response. Okay, now 1/2 into e power 3t u of t. Okay, this is term 1 minus 1/2 into e power minus t u of t. This is term 2. Okay, term 1, term 2 ఇది ఇక్కడ రాస్తాను. మనకు తెలిసిన టర్మ్ ఏంటి? h of t is equal to 1/2 into e power 3t u of t. Okay, this is term 1 minus 1/2 into e power minus t u of t. This is term 2. Term 1 and term 2. Okay, ఇది స్టాండర్డ్ టర్మ్. ఇది చేంజ్ అవుతూ ఉంటుంది. ఫస్ట్ కండిషన్. ఓకే, గ్రాఫ్ ఆల్రెడీ తెలుసు కదా మీకు, ఇలా రాసుకుంటారు గ్రాఫ్స్. ఇది మొత్తం కలిపి రాసేసాను. ఓకే, యూ హ్యావ్ టు రైట్ ఇండివిజువల్లీ. వెన్ ఇట్ ఈస్ RE of S less than -1, you have to write like this. Okay, when it is RE of S greater than, we have to write only this one. When it is lies between -1 and 3, you have to write this one only. Okay, graph అర్థమైనగా? Okay, now these are poles, so put cross marks. Okay, first possibility RE of S greater than 3. ఓకే, ఇక్కడే గ్రాఫ్ గీస్తున్నాను చూడండి. 3, so 3 greater than 3, so this is the possibility. Okay, this one is 4, so into mark. Okay, here -1 and 3, -1 and 3 left side the area. Okay, this is ROC. Okay, ROC sigma greater than 3. So this is the area. From this area, two poles on left side. Okay, two poles on left side. So this h of t is no change. Okay, so no change. Okay, ఈ పాయింట్ అర్థమైందా? These poles lies on left side of the area. So these two are casual. These two are casual. These two are casual and no change in the expression. So expression is same, h of t. Okay. Next. Next B. What is B? ROC RE of S less than -1. Okay. So this is -1. Less than -1 means this is the area. Okay. Now -1 and 3. Okay. Now ROC area is this one. Okay. Now -1 and 3 lies on the right side. Okay. So lies on the right side. Lies on the right side. Both. Okay. Both lies on right side. So both are anti-casual. Both are anti-casual. Both are anti-casual means for both terms you have to put minus and u of minus t. Okay. Now for this one, h of t is equal to -1/2 e power 3t u of minus t. In place of minus plus 1/2 e power minus t u of minus t. Okay. ఈ పాయింట్ అర్థమైంది కదా? Both poles are lies in the right side. Right side means it is anti-casual. Anti-casual means both terms should be changed. Okay, change with the minus and u of minus t. Okay, next, third condition. Third condition, ROC lies between -1 less than RE of S less than 3. Okay, so -1 and 3. Okay, -1, this is pole, 3 is a pole. So in between means this one. -1 is left side. Okay, -1 is left side. So it is casual. Next, 3 is on right side. 3 is on right side. So it is anti-casual. Okay, so this is no change and it has a minus u of minus t. Okay, this should be changed. Okay, 3 has this term. This term has 3. Okay, so this term is changed. Term 1 is changed. Term 2 is not changed. Okay, so term 1 is changed. -1/2 e power 3t u of minus t. Term 2 no change. -1/2 u of minus t u of t. Okay, these are the ROC. Okay, this is the advanced ROC and most difficult problem. Okay, he will give no clue, only he will tell about the what are the possibilities. Okay, so you have to find the poles and you have to find the possibilities, and with the possibilities you have to write this h of t, that is impulse response according to the casuality. Okay, that is casual or it is anti-casual. Okay, if it is lies on the left side or it is left on right, if it is lies on the right side. Okay, here lies on left side. Okay, Up to here, 9 is completed. Next one is 10th. Okay. Oh, 10th, not 10th. In 9 only, now it is just Z transform. Okay. In 9 only, now it is Z transform. Up to now discussed about the Laplace transformation model line. Now it is a model line Z transform. Model 9 Z transform. Okay, Z transform belongs to unit 5. Unit 5 part 2. Okay, so from here problems will be started. Okay, in Z transform you have only two types of formulas. Okay, you have only two types of formulas. Z transforms, two formulas only almost. Okay, already one formula we have already done. Most important formula is a power n, a power n u of n. This formula we write in reverse. Okay, so Z transform is 1 by 1 minus a z power minus 1. Whatever may be the a value, this should be here. Okay, so in this reverse direction, it is inverse Z transform. This is the only formula. Okay, always available in the each and every problem. Okay, next problem, next important formula is n is equal to 0 to infinity. N is equal to 0 to infinity. A power z minus 1 whole power n. Z transform. Okay, Z transform is whatever may be applied in the bracket power n. Okay, in bracket power n, that is a z power minus 1, that will comes under this value 1 by 1 minus a z power minus 1. Okay, so if it is 1 by 3 z power minus 1 whole power n, now this will be 1 by 1 minus 1 by 3 z power minus 1. Okay, sigma n is equal to 0 to infinity. Okay, if a has 1 by 3, it is 1 by 3. If it is 3, that is 3. Next, this formula I am writing in reverse direction. That is a 1 by 1 minus a z inverse. Okay, a z inverse means take 1 by z. Okay, so here this term is z. This term is z. Z by z minus 1. Z by z minus 1 is, what is the value here? A. So a power n u of n. Okay. If it is a is equal to 1 by 4, then it is 1 by 4 whole power n u of n. Okay. Suppose z by z minus 4. Okay. Inverse z transform is 4 power n u of n. Z by z minus 1 by 4. It is 1 by 4 whole power n u of n. Okay, like that. So z by z minus 4 or 1 by 1 minus 4 z inverse. Okay, both are same. Only three formulas. Okay, this is the first formula. This is the second formula. Okay, this is the first formula, this second formula, and this is the third formula. That is reverse. Okay, that is inverse Z transform. Only these three formulas are very, very important, and these formulas are these formulas will be okay. Another formula is there, fourth formula. Another formula, fourth formula, e power minus j omega n u of n. So Z transform is 1 by 1 minus, here whatever may be the value is there, this value comes here. Okay, so e power minus j omega into Z inverse. Okay, here whatever will be the value, that value comes here. Okay, e power minus j omega n. Here e power minus j omega, not n, e power minus j omega. Okay, these are the important 4 formulas, and this difference formulas also is there. Difference formulas. Okay, difference formulas means y of n minus 1, y of n minus 2. Y of n minus 1 is z power minus 1 y of z. Okay, it is minus 1 minus 1. Y of n minus 2. Already we know this formula, z power minus 2 y of z. Okay, these are this is a 5th formula. These 5 formulas for the total Z transform. These 5 formulas are enough for a total Z transform. Okay. Now, first problem. You have to find the n into delta of n. What is the Z transform? First of all, before that, we have to know what is the standard formula for Z transform. This is the standard formula for Z transform. Okay. Standard formula sigma. Sigma n is equal to minus infinity x of n z power minus n. In place of x of n, what is the formula here? N into delta of n. N into delta of n. Okay. So this value is 0. Okay. Next. To know the formulas only. Okay. To know the formulas. Now x of n value delta of n minus 1. Delta of n minus 1. So substitute in the value delta of n minus 1 z power minus 1. So this value is 1 when n is equal to 4. So this value will be 4. Okay. Minus infinity infinity, this value is 4. So z power, this value z power n. N value is 4. N value is 4. So z power minus 4. N plus 3. So here n is equal to minus 3. Okay. N is equal to minus 3. In place of z power minus n, put minus 3. Z cube. That like these are. Okay. So for this one, next 11th problem. 11th problem is very, very important problem. This one. Okay. This is the important problem in Z transform. Very, very important problem. Already put star marks here. Okay. So this is very, very important problem. From this, determine all possibility signal. All possibility signal. That is, already we know all possibilities means it is ROC. Okay. So we have to find ROC. Same procedure before for a Laplace transformation. Same procedure. Here also same procedure. But the difference is here Z transform. There is Laplace transformation. Okay. So for this one, this is the given question. For this is the given question. For this given question, Z power minus 1 is not preferable. Okay, so to calculate Z, multiply and divide with Z square. See here, multiply and divide with Z square. So 1 by 4 into Z, Z minus 1 by 4, 1 by 2, Z minus 1 by 4. Now, what is the 0? Here only Z is there. So Z is equal to 0. So 0 is Z is equal to 0. Now, what are the poles? Z is equal to 1 by 2, Z is equal to 1 by 4. Z is equal to 1 by 2, Z is equal to 1 by 4. So 2 poles and 1 0. Okay. So here possibilities is 3 possibilities. 3 possibilities. What is the possibility? 1 by 2. 1 by 2 means 0.5. 1 by 4 means 0.25. So less than 1 by 4, greater than 1 by 2, in between 1 by 4 and 1 by 2. These are the 3 possibilities. Okay. Same as Laplace transformation. Okay. Now, the only already I told one important point in Z while calculating partial fractions. Okay, in Z while calculating partial fractions, one Z term is always there. Okay, one Z term will be always in numerator. So to minimize the calculations, you have to transfer this to left hand side. So xz by z, xz by z. Okay, this is the value. So now we can easily apply partial fractions. Okay, partial fractions C1. Okay, here C1 C2 we can name it as A1 B, A and B. Okay, A by Z minus 1 by 2, B by Z minus 1 by 4. So Z is equal to 1 by 4, Z is equal to 1 by 2, Z is equal to 1 by 4. So Z minus 1 by 2 for this one, Z minus 1 by 2 into this value. So this one get cancelled. So this is the value, and substitute. This is the answer. So C1 is equal to 1, C2 is equal to -1. Okay. Now again multiply this term this here. Okay. Again multiply this term here. Now see here. Now see here. This is the formula. Okay. This is the formula, most important formula. Okay. Z by Z minus 4. So Z by Z minus 4. Okay. This formula same. Okay. Now see here. Z by Z minus A, Z transform is A power n u of n. Okay. These Z by Z minus 1 can be written as 1 by 1 minus A Z power minus 1. Okay. But in practical, this is the formula. Okay. This is the form. Okay. In practical, this is the form. Now, what the formula? Z by Z minus A, Z transform is A power n u of n. Okay. So now here Z by Z minus 1 by 2. Okay. This Z is transferred to here. So Z by Z minus 1 by 2. In place of A, what is the value? 1 by 2. So A power n, that is 1 by 2 power n u of n minus 1 by 4. 1 by 4 over power n u of n. Very easy. Okay. Now here standard ROC is modulus of Z circle greater than 1. Unity circle is outside the outermost pole. Okay. So 1 by 2. 1 by 2 means 0.5. Here 1. So the circle, when you draw circle, Z means you have to take circles. Okay. See here. You have to take circles. So this is the unity circle. In next page we have circles. Unity circle. Unity circle means modulus of Z greater than 1. Okay. With this circle only, always you have to do comparison. Okay. In Z transform, you have to do comparison. So here, what is the value? Z is equal to 1 by 2. That is, this is the circle. Okay. This is the circle. So unity circle should be always inside. Okay. Unity circle should be always inside. Okay. Always inside the pole. Then only it is stable. Okay. Otherwise, it is not stable. Okay. Let us see here. Previously, this is the first diagram. Modulus of Z 1 by 2. Okay. Modulus of Z 1 by 2. Okay. Now this is the unity circle. Outside circle is the unity circle. Okay. So these here okay, here these type of problems, these type of diagrams in Z transform are called a pole zero pattern. Okay. In question they will ask that write the pole zero pattern of this question, that means diagrams. Okay. So here Z is 0, Z has a 1 by 4 and 1 by 2. Okay. These are the poles. This is 0. Okay. 0 pole. And this external circle is modulus of Z greater than 1. That is unity circle. Okay. Always compare with this unity circle. Okay. Here unity circle is inside. Okay. Unity circle is inside. Okay. Unity circle is inside means it is somewhat casual. Okay. Casual, and stability is unstable. See here, less than 1 by 4. Okay. Here unity circle is outside. Okay. Unity circle is outside, and this is also inside. Here unity circle is between unity circle. Here also unity circle is outside. Unity circle is outside, and both these two values, both 1 by 4 means 0.25 and 1.0.5. These two are lies in between the shaded path. Okay. The shaded path. So every circle is outside. Here unity circle is outside. Here unity circle is outside. Here unity circle is outside. Okay. So here both poles are lies outside. So change